Hello, hi everyone. I welcome you all to the Vedanta Karnataka and ನಾನು ನಿಮ್ಮ ಮಾಸ್ಟರ್ ಟೀಚರ್ ಋತಿಕಾ ಮ್ಯಾಮ್. ಸೊ ಇವತ್ತಿನ ಚಾಪ್ಟರ್ ಏನು ಮ್ಯಾಮ್? ಸೊ ಹಿಂದ್ಗಡೆ ಕಾರ್ಟೂನ್ಸ್ ಕಾಣ್ತಿದ್ದಾವೆ ಏನು ಮ್ಯಾಮ್ ಇವತ್ತು? ಸೊ ಬಯೋಮಾಲಿಕ್ಯೂಲ್ಸ್ ಇಸ್ ದ ಟುಡೇಸ್ ಚಾಪ್ಟರ್. ಸೊ ಸ್ವಲ್ಪ ಹುಡುಗರಿಗೆ ಬಯೋಮಾಲಿಕ್ಯೂಲ್ಸ್ ಅದೇ ಫುಲ್ ಖುಷಿ, ಬಿಕಾಸ್ ಬಯೋಮಾಲಿಕ್ಯೂಲ್ಸ್ ಇಂದ ಎಷ್ಟು ಈಸಿ ಮಾರ್ಕ್ಸ್ ಬೀಳುತ್ತಂದ್ರೆ ಡೈರೆಕ್ಟ್ ಕ್ವಶನ್ಸ್ ಇರುತ್ತಲ್ಲ, ಅದಕ್ಕೆ ಹುಡುಗರಿಗೆ ಬಹಳ ಈಸಿ ಅಂತ ಅನಿಸುತ್ತೆ. ಸೊ ಈವನ್ ಐ ವಾಸ್ ಅ ಪರ್ಸನ್ ವೆನ್ ಐ ವಾಸ್ ಡೂಯಿಂಗ್ ದ ಸೈನ್ಸ್, ನನಗೂ ಬಯೋಮಾಲಿಕ್ಯೂಲ್ಸ್ ಅಂದರೆ ಬಹಳ ಇಷ್ಟ ಆಗ್ತಿತ್ತು, ಬಿಕಾಸ್ ಫುಲ್ ಈಸಿ ಇರ್ತಿತ್ತು ಚಾಪ್ಟರು, ಮತ್ತು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಈಸಿ ಆಗ್ತಿತ್ತು, ಮತ್ತು ಎಲ್ಲ ಕ್ವಶನ್ಸು ಡೈರೆಕ್ಟು ಆಯಿತಾ. ಸೊ ದಿಸ್ ಇಸ್ ಆಲ್ಸೋ ಮೈ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ವಿಚ್ ಐ ಟೋಲ್ಡ್ ಯು. ಓಕೆ, ಸೊ ಹಾಯ್ ಎವ್ರಿ ಒನ್. ಆಮ್ ಐ ವಿಸಿಬಲ್ ಆ್ಯಂಡ್ ಆಡಿಬಲ್ ಪ್ರಾಪರ್ಲಿ ಟು ಎವ್ರಿ ಒನ್? ಸರಿಯಾಗಿ ವಿಸಿಬಿಲಿಟಿ ಇದೆನಾ? ಆಡಿಬಲ್ ಇದೆನಾ ಸರಿಯಾಗಿ? Yes, then ಇವತ್ತಿನ class start ಮಾಡೋಣ. Yes, so let's start the class. So let me check once am I audible or no. Yes. So let's start the class. So biomolecules first ಹೇಳೋದಂದ್ರೆ ಈ ಚಾಪ್ಟರ್ ಇಂದ ಎಲ್ಲ ಕ್ವಶನ್ಸ್ ಮೋಸ್ಟ್ ಪ್ರಾಬಬಲಿ ಡೈರೆಕ್ಟ್ ಆಗಿ ಕೇಳ್ತಾರೆ. ಓಕೆ, ಮೋಸ್ಟ್ ಪ್ರಾಬಬಲಿ ದ ಕ್ವಶನ್ಸ್ ವಿಲ್ ಬಿ ಆಸ್ಕ್ ಡೈರೆಕ್ಟ್ಲಿ ಇಟ್ ಸೆಲ್ಫ್, ನಾಟ್ ಟು ವರಿ ಮಚ್ ಫ್ರಮ್ ದಿಸ್ ಚಾಪ್ಟರ್. ಬಟ್ ಫ್ರಮ್ ಇನ್ KCET ಪ್ರಾಸ್ಪೆಕ್ಟಿವ್ ವ್ಯೂನಲ್ಲಿ KCET ಅಲ್ಲಿ ಈ ಚಾಪ್ಟರ್ ಇಂದ ಆಲ್ಮೋಸ್ಟ್ ಟೂ ಕ್ವಶನ್ಸ್ ಅನ್ನ ಕೇಳ್ತಾರೆ. ಟೂ ಕ್ವಶನ್ಸ್ ಅನ್ನ ಕೇಳಬಹುದು. ಕ್ಲಿಯರ್? ಸೊ ಈ ಟೂ ಕ್ವಶನ್ಸ್ ಅನ್ನ ಓದ್ಬೇಕಂದ್ರೆ ಫುಲ್ ಚಾಪ್ಟರ್ ಓದ್ಬೇಕು, ರೈಟ್? PU ಬೋರ್ಡ್ ನಲ್ಲಿನೂ ಕ್ವಶನ್ಸ್ ಚೆನ್ನಾಗಿ ಬೀಳುತ್ತೆ. ಅಂಡ್ ಮೇನ್ ಪ್ರಾಬಬಲಿ ಈ 2 ಮಾರ್ಕ್ಸ್ ಏನ್ ಹೇಳ್ತಿದ್ದೇನಲ್ಲ, that can be scored easily. ಸೊ ಯಾಕೆ ಮ್ಯಾಮ್ಸ್ ಈಸಿಲಿ ಹೇಗೆ ಸ್ಕೋರ್ ಮಾಡ್ಕೋಬಹುದು ಇದನ್ನ ಅಂತ ನೀವು ಯೋಚನೆ ಮಾಡ್ತಿದ್ದಾರಾ? ಎಸ್, ವೈ? ಬಿಕಾಸ್ ವೈ ಆಮ್ ಐ ಟೆಲ್ಲಿಂಗ್ ಇಸ್, ಸೊ ಈ ಚಾಪ್ಟರ್ ಇಂದ ಎಲ್ಲ ಕ್ವಶನ್ಸ್ ಡೈರೆಕ್ಟ್ ಆಗಿ ಕೇಳ್ತಾರೆ. ಏನಪ್ಪ ಬಯೋಮಾಲಿಕ್ಯೂಲ್ಸ್, ಅದರ ಪ್ರಾಪರ್ಟೀಸ್ ಏನು, ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸ್ ಏನು, ಇದ್ರ ಸ್ಟ್ರಕ್ಚರ್ ಏನು, ಸೊ ಇದೇ ಅಂತ ತರನೇ ಕ್ವಶನ್ಸ್ ಜಾಸ್ತಿ ಬೀಳೋದು. ಸೊ ಇಟ್ಸ್ ಜಸ್ಟ್ ಲೈಕ್ ಲಿಟಲ್ ಬಿಟ್ ಬಯಾಲಜಿ ವಿಲ್ ಬಿ ಇನ್ಕ್ಲೂಡೆಡ್ ಇನ್ ಇಟ್, ಆಯ್ತಾ? ಸ್ವಲ್ಪ ಬಯಾಲಜಿ ಇನ್ಕ್ಲೂಡೆಡ್ ಇರುತ್ತೆ ಈ ಚಾಪ್ಟರ್ ನಲ್ಲಿ. ಸೊ ನೀವು ಆಲ್ರೆಡಿ ಈ ಚಾಪ್ಟರ್ಸ್ ಅನ್ನ ಓದಿದ್ದೀರಾ ನಿಮ್ KCET ಪ್ರಿಪರೇಷನ್ ನಲ್ಲಿ ಅಂದ್ರೆ ಇದರ ಬಗ್ಗೆ ಕಾನ್ಸೆಪ್ಟ್ ಗಿಂತ PYQs ಜಾಸ್ತಿ ಸಾಲ್ವ್ ಮಾಡಬೇಕು. ನನ್ನ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಪ್ರಕಾರ ಹೇಳ್ತಿದ್ದೇನೆ, ಇಫ್ ಯು ಪೀಪಲ್ ವಿಲ್ ಸಾಲ್ವ್ ಮೋರ್ PYQs ಇಟ್ ವಿಲ್ ರಿಯಲಿ ಹೆಲ್ಪ್ ಯು ಪೀಪಲ್ ಅ ಲಾಟ್. ಓಕೆ, PYQs ಅನ್ನ ಚೆನ್ನಾಗಿ ಫುಲ್ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿ. ಓಕೆ, ಪ್ರಾಕ್ಟೀಸ್ ಇಸ್ ವೆರಿ ಮಚ್ ನೆಸೆಸರಿ ಫಾರ್ ದ PYQs ಫ್ರಮ್ ದಿಸ್ ಚಾಪ್ಟರ್. ಆಯ್ತಾ? So let's start with the chapter without wasting the time now. First, let us learn about the introduction of the chapter. Okay, introduction of the chapter. That is, living systems are made up of various complex biomolecules like nucleic acid, like the nucleic acid which is also present, carbohydrates which are present, proteins which we eat it daily, lipids and etc. These are the things which are actually necessity. Namak necessary ide daily life nalli, right? So daily life nalli ivella necessity ide. You need to eat, you need to be active while eating these things, and mainly nam body nalli ivella ide. Then carbohydrates and the proteins are essential constituents of our food. Yes, carbohydrates ಅಂದ್ರೆ ರೈಸ್. ಸ್ವಲ್ಪ ಮಂದಿಗೆ ರೈಸ್ ಅಂದ್ರೆ ಭಾಳ ಸೇರುತ್ತಲ್ಲ, ರೈಟ್? ಸೊ ಎಲ್ಲರಿಗೂ ರೈಸ್ ಅಂದ್ರೆ ಫುಲ್ ಸೇರುತ್ತೆ, ಎಲ್ಲರಿಗೂ ಅನ್ನ ಕುಂತು ದಿವ್ಸಕ್ಕೆ ಒಂದ್ಸಲ ಬೇಕೇ ಅಪ್ಪ. ಓಕೆ, ಸೊ ಏನಾದ್ರೂ ಮಮ್ಮಿ ಚಪಾತಿ ಮತ್ತೆ ಬಾಜಿ ಮತ್ತೆ ರೈಸ್ ದಾಲ್ ಮಾಡಿದ್ರೆ ಫಸ್ಟ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಹೋಗೋದು ರೈಸ್ ದಾಲೆ. ದಟ್ ಇಸ್ ಅ ಸ್ಟೇಬಲ್ ಫುಡ್ ಫಾರ್ ಅವರ್ ಇಂಡಿಯನ್ ಪೀಪಲ್, ರೈಟ್? ಸೊ ಆಮೇಲೆ ಇನ್ ಅಡಿಷನ್ ಆಫ್ ಸಮ್ ಸಿಂಪಲ್ ಪ್ರೋಟೀನ್ಸ್ ಅಂತ ಗೊತ್ತಿರಬೇಕು. ಈಗಷ್ಟು ಎಷ್ಟು ಹೈಪ್ ಆಗಿದೆ ಎಲ್ಲರದು ಜಿಮ್ ಹೋಗೋದಂದ್ರೆ, ಯು ಕ್ಯಾನ್ ಸೇ ಎವ್ರಿ ಒನ್ from 10th standard only students are going for the gym, right? So gym ಗೊಂಟಿದ್ರೆ ಅಂದ್ರೆ ಪ್ರೋಟೀನ್ಸ್ ಬೇಕಲ್ಲ, ರೈಟ್? ಸೊ ನಾನು ಕುಂತ ಇವತ್ತು ಏನ್ ತಿಂದಿಯಪ್ಪ ಪ್ರೋಟೀನ್ಸ್ ಅಂತ ಚೆಕ್ ಮಾಡ್ಕೊಂತಾನೆ ಇರಬೇಕು, ರೈಟ್? ಸೊ in addition of some simple molecules like mineral salts, vitamins also play a very important role in the function of the organisms. Yes, so these will also minerals, salts, vitamins ಇವೆಲ್ಲನೂ ಬಹಳ ಇಂಪಾರ್ಟೆಂಟ್ ನಮ್ಮ ಡೈಲಿ ಲೈಫ್ಗೆ. ಸೊ ಇವೆಲ್ಲ ಡೈಲಿ ಲೈಫ್ ಇರ್ತಿರ್ಲಿಲ್ಲ ಅಂದ್ರೆ ವಿ ಕ್ಯಾನ್ ಸರ್ವೈವ್ ಅವರ್ ಬಾಡಿ. ನನ್ನ ಬಾಡಿನಲ್ಲಿ ಫಂಕ್ಷನ್ ಸರಿಯಾಗಿ ಆಗಲ್ಲ. ಓಕೆ, ಫಂಕ್ಷನ್ಸ್ ಸರಿಯಾಗಿ ಆಗಲ್ಲ. ಕ್ಲಿಯರಾ? Definition comes what? Chemically, the carbohydrates may be defined as the optically active polyhydroxyaldehydes. Defined as optically active polyhydrates, aldehydes or ketones, or the compounds which produce such as units as hydrolysis. Clear? Done. Next, What is the meaning of an carbohydrates? Carbohydrates andre ಏನು? You actually ಏನಪ್ಪ ಕರೀತಾರೆ carbohydrates ಗೆ, but ನಮ್ಮ ಬಾಡಿಗೆ ಎದಕ್ಕೆ ಇದು ಇಂಪಾರ್ಟೆಂಟ್ ಇದೆ? So carbohydrates like hydrates of carbon, it is actually a hydrates of a carbon and are naturally occurring compounds. So ಇವೆಲ್ಲ ಏನು? Naturally occurring compounds. These are having a general formula like C6H22. One second guys. Color change ಮಾಡ್ಕೊಳ್ಳೋಣ. C6CXH2OY. Okay, CXH2OY. Done. So this is also important. Okay, ಇದನ್ನ ನೆನಪಿಟ್ಕೊಳ್ಳಿ ಅದರ ಜನರಲ್ ಫಾರ್ಮುಲಾ ಅನ್ನ, ರೈಟ್? So next, which are consistently produced in the nature and they participate in many important biomolecule reactions. So ಯಾವ್ಯಾವ biomolecule reactions, like example ಏನು ಇರಲಿ, ನಾವು ಏನು ತಿಂತೇವಲ್ಲ ಡೈಲಿ ಲೈಫ್ ನಲ್ಲಿ ಅದರಲ್ಲಿ ಕಾರ್ಬೋಹೈಡ್ರೇಟ್ಸ್ ಇರುತ್ತೆ. ಸೊ ಕಾರ್ಬೋಹೈಡ್ರೇಟ್ಸ್ ಕಡಿಮೆ ತಿನ್ಬೇಕಪ್ಪ, ಕಾರ್ಬೋಹೈಡ್ರೇಟ್ಸ್ ಜಾಸ್ತಿ ತಿನ್ಬಾರ್ದು, ಮತ್ತೆ ಕಾರ್ಬೋಹೈಡ್ರೇಟ್ಸ್ ಬಾಡಿಗೆ ಬೇಕೋ ಬೇಡೋ, ಜಾಸ್ತಿ ಬೇಡದು. ಎಸ್, ಕಾರ್ಬೋಹೈಡ್ರೇಟ್ಸ್ ಜಾಸ್ತಿ ಬಾಡಿಗೆ ನೆಸೆಸಿಟಿ ಇಲ್ಲ. ಹೌ ಮಚ್ ಇಟ್ಸ್ ನೆಸೆಸರಿ ಫಾರ್ ಅ ಪರ್ಸನ್, that much only we should eat it. In case that increase ಆಕೊಂತ ಹೋದ್ರೆ carbohydrates, so it might affect our body also. ಆಯ್ತಾ? ಸೊ ಯಾವ್ಯಾವ ತರ ಇರುತ್ತೆ? ಗ್ಲೂಕೋಸ್, C6H12O6, ಆಮೇಲೆ ಫ್ರುಕ್ಟೋಸ್, ಸೆಲ್ಯುಲೋಸ್, ಸ್ಟಾರ್ಚ್, this all are going to be what? Carbohydrates. Clear? So carbohydrates are what? Naturally occurring, right? What is its general formula? CXH2OY, right? This is general formula. And here, which are consistently produced what? Natural, and it participates in very important concept, that is biochemical reaction. Clear? It will participate in biochemical reactions. Clear? Next comes sucrose. Sucrose means what? Yes. Sucrose andre ಏನು? Sucrose, that is also called as a cane sugar, that is C12H22O11. ಈ ತರ ಫಾರ್ಮುಲಾಸ್ ಫುಲ್ ಬರೋದು ಈ ಚಾಪ್ಟರ್ ನಲ್ಲಿ, ಮತ್ತೆ ನೆನಪಿಟ್ಕೊಳ್ಳೋದು ಈ ಚಾಪ್ಟರ್ ಇಂದ ಅದೇ ಮೇನು. ಓಕೆ, ಯು ನೀಡ್ ಟು ರಿಮೆಂಬರ್ ದಿಸ್ ಚಾಪ್ಟರ್ ಓನ್ಲಿ ಟೂ ಮಚ್, ಮೀನ್ಸ್ ಇದನ್ನ ನೀವು ಫುಲ್ ನೆನಪಿಟ್ಕೊಳ್ಳೋಕೆ ಬೇಕೇ ಬೇಕು. ತಿಳಿತಾ? Understood? Sucrose, that is also called as cane sugar. Okay, that is C12H22O11, and a maltose, that is also called as a malt sugar, that is also called as what? C12H2O11. C12H2O11. Malt sugar andre C12, carbon 12 irutte, and H2O and 11. Illi C12H22O11. H22O11. Sucrose. So in sucrose will be actually used in our daily life a lot. ಈಗಂತೂ ಏನಾಗಿದೆ ಅಂದ್ರೆ the people are moving towards the sucrose actually. So this is actually what? It's not, if you consume more, it will be harmful. If we are consuming in a proper amount, then it is not harmful to us. Actually, more than that, a common sugar, that is cane sugar, is also very much little bit dangerous. Okay, but some of the compounds which have a formula according to the H2OY are not known as a carbohydrates. For ಸ್ವಲ್ಪ compounds means exceptional ಇದು. Okay, ಸ್ವಲ್ಪ carbon compounds ಇದೆ, means carbonyl compounds ಇದೆ, ಅವತ್ರದ್ದು ಈ ಜನರಲ್ ಫಾರ್ಮುಲಾ ಇಲ್ಲ. ಯಾವ್ಯಾವದು? ಎಕ್ಸಾಂಪಲ್ CH2, C2H2O2, C3H2O3. So this is formaldehyde, acetic acid and lactic acid. So this three things which are present, no, ವೇನ್ ಮೂರು ಇದಾವಲ್ಲ, ಅವು actually they are not a carbonyl compounds or carbohydrates. So ಇವು ಮೂರು carbohydrates ಇಲ್ಲ. But also the general formula is in that it's similar way. General formula actually similar way ನಲ್ಲಿನೇ ಇದೆ. ಕ್ಲಿಯರಾ? ಸೊ ಇದೊಂದು ಎಕ್ಸೆಪ್ಷನಲ್ ನೀವು ನೆನ್ಪಿಟ್ಕೋಬೇಕು. ತಿಳಿತಾ ಎಲ್ಲರಿಗೂ? Understood carbohydrates everyone? ಸೊ ಕಾರ್ಬೋಹೈಡ್ರೇಟ್ಸ್ ಜಾಸ್ತಿ ತಿನ್ಬಾರ್ದು, ಜಾಸ್ತಿ ತಿಂದ್ರೆ ಎಫೆಕ್ಟ್ ಆಗುತ್ತೆ, ಆದ್ರೆ ಕಡಿಮೆ ತಿಂದ್ರೂ ಎಫೆಕ್ಟ್ ಆಗುತ್ತೆ. ನೆಕ್ಸ್ಟ್, there are many compounds which shows chemical behavior of the carbohydrate but also not confirm the general formula of C6H12, C6H22Y. Such as means what? Some ಸ್ವಲ್ಪ compounds ಇದೇನೆ, ಏನ್ chemical behavior will actually show, means what? They will act like a carbohydrates but they are not. Okay, carbohydrate ತರ act ಮಾಡ್ತಾರೆ, ಎಲ್ಲ acting ಅದರ ತರನೇ ಇರುತ್ತೆ. But like ನಾವು ಸಣ್ಣ ಹುಡುಗರದ್ದು ಆಟ ಆಡ್ತೇವಲ್ಲ, I am becoming a doctor, I am becoming an engineer, I am becoming a teacher. So ಆ ತರ ಏನು acting ಮಾಡ್ತಾರಲ್ಲ, ಆ ತರ acting ಮಾಡುತ್ತೆ but they are not a carbohydrates. ಸೀದಾ ಎಕ್ಸಾಂಪಲ್ C5H10O4, that is also 2-deoxyribose. C6H12O5, that is also called as Ramanus. Clear? So these are the two things which we can give the example. Next, carbohydrates, the energy sources of living beings, are the most abundant organic compound around us. So in carbohydrates, they all, the energy sources of this living beings are actually most abundant. Most abundant organic compounds around us. Clear? So in a metabolic process, in the living beings, glucose is usually oxidized. So in the metabolic process, glucose yavagalu oxidize agutte. So glucose will always get oxidized into carbon dioxide and water. Into carbon dioxide and water to provide, to provide the energy to the cell for their functioning. To provide the cell to the for the purpose of functioning, we are going to use it. Clear? So, ಈಗ carbohydrates ಅಂದ್ರೆ ಏನೇನು ನೆನಪಿಟ್ಕೋಬೇಕು? Carbohydrates means what? It's a very important part of our life. Carbohydrates ಇದ್ರೇನೆ the survival of our body will be properly. Clear? ಈಗ ಜನರಲ್ ಇಕ್ವೇಶನ್ ಏನಿದೆ ಅಂದ್ರೆ C6H2OY ಇದೆ. ಸ್ವಲ್ಪ C6H2OY ತರ ಇರಲ್ಲ. Means the general equation is that. But some of the compounds are present. Their general equations are like that, but they are not carbohydrates. That one function you can write it down. Second function ಏನು ಬರಿಬಹುದು? C6H2OY ಆ ತರ actually act ಮಾಡುತ್ತೆ. Means some of the compounds will act like they are actually acting like a carbohydrates, but they are not carbohydrates. Clear? So like this, you people can write the functions of them. Clear? Next, classification of carbohydrates. Here the carbohydrates are actually classified on the basis of their behavior. How actually they are getting behaved on the basis of those behavior itself. First, carbohydrates is sugar and non-sugar. Sugar means what? Sweet in taste, crystalline and soluble in water. Okay, it's crystalline and soluble in water. Here non-sugar, that is polysac, tasteless and amorphous solid, non-crystalline and insoluble in water. It is insoluble in water. Clear? These yields many sweet monosach on acidic hydrolysis. Monosach on acidic hydrolysis. ಈಗ ಆ sugar which is sweet in taste and crystalline and it is soluble in the water, ಆದ್ರೂ ಏನೇನ್ types ಇದೆ? So ಅದರಲ್ಲಿ ಎರಡು ತರ type ಇದೆ. That is monosaccharides and oligosaccharides. It has two types. Which are those? Monosaccharides and oligosaccharides. So this is a small flow chart. Okay, classification of carbohydrates do flow chart. So ಈ ತರ flow chart ನೀವು ಎಲ್ಲದಕ್ಕೂ ಮಾಡ್ಕೊಂತ ಹೋಗಬಹುದು. ಆಯ್ತಾ? Understanding? Hi. So ಈ ತರ ಇದನ್ನ ಮಾಡ್ಕೋ ಕಂಟಿನ್ಯೂ ಆಗಿ ನೀವು ಪೀಪಲ್ ಕ್ಯಾನ್ ಇವನ್ ಪ್ರಿಪೇರ್ ದ ಫ್ಲೋ ಚಾರ್ಟ್ಸ್ ಆಲ್ಸೋ. ಓಕೆ, ಫ್ಲೋ ಚಾರ್ಟ್ಸ್ ಮಾಡಿದ್ರೆ ನಿಮಗೆ ಏನು ಹೆಲ್ಪ್ಫುಲ್ ಆಗುತ್ತಂದ್ರೆ ನಿಮಗೆ ಆ ಕ್ಲಾಸಿಫಿಕೇಶನ್, ಈಗ ನಾ ಹೇಳ್ದೆಪ್ಪ ಡೈರೆಕ್ಟ್ ಆಗಿ ಮ್ಯಾಮ್ ಕ್ಲಾಸಿಫಿಕೇಶನ್ ಆಫ್ ಕಾರ್ಬೋಹೈಡ್ರೇಟ್ಸ್ ಅಂತ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತಿದ್ದಾರೆ. ಇಫ್ ಯು ಹವ್ ಡನ್ ದ ಫ್ಲೋ ಚಾರ್ಟ್ ಮೀನ್ಸ್ ಈ ತರ ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ಟಿದ್ರೆ ನಿಮಗೆ ಈಸಿ ಆಗಿಬಿಡುತ್ತೆ. ಒಂದ್ಸಲ ಹಿಂಗೆ ನೋಡ್ಕೊಂಡ್ಬಿಟ್ಟು ಪಾಪ ರಿವಿಷನ್ ಮಾಡ್ಕೊಂಡು ಸೊ ಓಕೆ ಇದಂದ್ರೆ ಇದು ಸೊ ಇದು ನಿಮಗೆ ಫ್ಲಾಶ್ ಬ್ಯಾಕ್ ಹಾಕೋಂತ ಹೋಗುತ್ತೆ. ದಟ್ ಇಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಓಕೆ, ಸೊ sugar matte sweet in taste and it is going to be soluble in a water because water in that is going to act like a solvent and a solute is going to act like a sugar. Clear? That together called as a solution. So monosaccharides monosaccharides and oligosaccharides. In monosaccharides, we have again two types. One is aldose and ketose. We will learn all those things. Okay. So monosaccharides nalli ಎರಡು type ಇದೆ ಮತ್ತು aldose ಮತ್ತೆ ketose ಇದೆ. Clear? Next comes the oligosaccharides. In oligosaccharides, which are present disach, that is also called as sucrose, maltose, lactose. We will be learning what? Sucrose, maltose and lactose. Clear? So here in a monosaccharides, we are going to learn oligosaccharides. This monosaccharides we are going to read aldose and ketose, and in oligosaccharides sucrose, maltose and lactose. And next comes the stearase. This is also called as raffinose. Okay, so raffinose anta karitare. Next comes the tetra, that is also called as tetrose. It is also called as tetrose. So these are the few types which we are going to learn it today. ಆಯ್ತಾ? ಸೊ ಅದ್ರ ಸಲುವಾಗಿ ಹೇಳೋದು ಈ ಕಾರ್ಬೋಹೈಡ್ರೇಟ್ಸ್ ಎರಡು ತರ ಡಿವೈಡ್ ಆಗಿದೆ. ಒಂದಿರೋದು ಶುಗರು, ಇನ್ನೊಂದಿರೋದು ನಾನ್ ಶುಗರು. ಶುಗರ್ ನಲ್ಲಿ ಎರಡು ಟೈಪ್ ಇದೆ, ಮೋನೋಸ್ಯಾಕರೈಡ್ಸ್ ಅಂಡ್ ಆಲಿಗೋಸ್ಯಾಕರೈಡ್ಸ್. ಆ ಮೋನೋಸ್ಯಾಕರೈಡ್ಸ್ ನಲ್ಲಿ ಅಲ್ಡೋಸ್ ಮತ್ತೆ ಕೀಟೋಸ್ ಇದೆ. ಮತ್ತೆ ಆಮೇಲೆ ಆಲಿಗೋಸ್ಯಾಕರೈಡ್ಸ್ ನಲ್ಲಿ 3 ಟೈಪ್ಸ್ ಇದೆ. ಫಸ್ಟ್ ವಿ ವಿಲ್ ಬಿ ಲರ್ನಿಂಗ್ ಅಬೌಟ್ ಡೈಸಾಕ್ ಅಂಡ್ ನೆಕ್ಸ್ಟ್ ವಿ ವಿಲ್ ಬಿ ಲರ್ನಿಂಗ್ ಅಬೌಟ್ ಟ್ರೈಸಾಕ್ ಅಂಡ್ ಅ tetra. Clear? These things we will learn it in the detailed way right now. Okay. First comes the monosaccharides, that is also called as a very simple sugar. So monosaccharides again karitare simple sugar anta karitare. Clear? So these are the sugars which cannot be hydrolyzed into smaller molecules. Okay, that cannot be hydrolyzed from the smaller molecules. Andre enu hydrolyze ಮಾಡ್ಲಿಕ್ಕೆ ಬರಲ್ಲ ಅದಕ್ಕಿಂತ ಸಣ್ಣ ಇರೋ molecules ತಂದ ಆಯ್ತಾ. So almost everything will get hydrolyzed, but here ಇದಕ್ಕಿಂತ ಏನಾದರೂ ಕಡಿಮೆ ಇದ್ರೆ ಇದಕ್ಕಿಂತ ಕಡಿಮೆ molecule ಇದ್ರೆ it can't be hydrolyzed. Okay, and then general formula for this is H2NON. Okay, this is very important, guys. So different color let's take. Okay, okay. Now, about 20 monosaccharides are known as exist in the nature. So, about almost 20 monosaccharides are known. So, saccharides, monosaccharides ಗೊತ್ತಿದೆ ನಮಗೆ almost 20 saccharides we know. 20 we know almost. Okay. So, ಅದರಲ್ಲಿ that will exist in the nature, and some examples are fructose, glucose, ribose, etc. Fructose, glucose, ribose and etc. Clear? So monosaccharides andre eno, first they are actually a simple sugars. First thing, general equation will come CnH2nON, H2nON. Clear? Then afterwards 20 monosaccharides has been present in the nature right now. Clear? And then if a CHO group is present in the monosaccharides, then it is known as aldose. If aldose is actually called as what? Where the CHO group is present. CHO group is there, aldose anta karitare. Wherever it is getting connected with the CHO, that is all called as aldose. ಇಷ್ಟೇ ನೆನಪಿಟ್ಕೊಳ್ಳಿ aldose ಅಂದ್ರೆ ತಿಳಿತಾ. Next, if in case C double bond O group is being present in the monosaccharide, then that is known as ketose. That is known as what? Ketose. Ketose means what? If in case C double bond O is present. Okay, C double bond O present idre ketose anta karitare, aldose ge CHO idre aldose anta karitare. Clear? So you ಎರಡು types monosaccharides nalli ide. Monosaccharides means what? CnH2nON ಆ ಜನರಲ್ ಫಾರ್ಮುಲಾ ನಲ್ಲಿ ಇದ್ರೆ monosaccharides ಅಂತ ಕರೀತಾರೆ. ಸೊ ಈ monosaccharides ನಲ್ಲಿ ಎರಡು ಟೈಪ್ಸ್ ಇದೆ. ಒನ್ ಇಸ್ aldose, ಒನ್ ಮೋರ್ ಇಸ್ ketose. ಸೊ aldose ನಲ್ಲಿ ಹೇಗೆ ಐಡೆಂಟಿಫೈ ಮಾಡ್ತಾರೆ aldose? Wherever it has a group of CHO, that all called as the aldose. In case C double bond O ಇದ್ರೆ ಅದಕ್ಕೆಲ್ಲ ketose ಅಂತ ಕರೀತಾರೆ. Simple to understand, right? Simple ಇದೆಲ್ಲ ಚಾಪ್ಟರ್, ಅದಕ್ಕೆ ಹೇಳೋದು ಸಿಂಪಲ್ ಚಾಪ್ಟರ್ಸ್ ಅನ್ನ ಓದಿ ಫಸ್ಟ್. ಓಕೆ, ಸಿಂಪಲ್ ಚಾಪ್ಟರ್ಸ್ ಇಂದ ಓದಿದ ತಕ್ಷಣ ನಿಮ್ ಎನರ್ಜಿ ಬೂಸ್ಟ್ ಆಗುತ್ತೆ. ಸೊ ನಿಮ್ಗೆ ಯಾವಾಗ ಎನರ್ಜಿ ಬೂಸ್ಟ್ ಆಗುತ್ತೆ? ವೆನ್ ಯು ಪೀಪಲ್ ವಿಲ್ ಲರ್ನ್ ಸಿಂಪಲ್ ಚಾಪ್ಟರ್ಸ್. ಸ್ವಲ್ಪ ನಿಮಗೆ ಈಸಿ ಅನ್ಸುತ್ತೆ, ಓ ಇಟ್ಸ್ ಓಕೆ, ದಿಸ್ ಇಸ್ ಈಸಿ, ಓಕೆ ನಾನು ಮಾಡಬಹುದು. ಅದಕ್ಕೇನಾಯ್ತು, ಒಂದೊಂದು 2-3 ಚಾಪ್ಟರ್ಸ್ ಜಾಸ್ತಿ ಡಿಫಿಕಲ್ಟ್ ಇದ್ರೆ ಅವನು ಮಾಡೋಣ, ಇವನೇ ಮಾಡ್ತಿದ್ದೇನಂತೆ ಅವನೇನು ಎಷ್ಟು ಪ್ರಾಬ್ಲಮಾ? ಇಲ್ಲಲ್ಲ. ಸೊ ಅದಕ್ಕೆ ಹೇಳೋದು ಈಸಿ ಚಾಪ್ಟರ್ಸ್ ಅನ್ನ ಓದಿದ್ರೆ ನಿಮ್ಗೆ ಎನರ್ಜಿ ಬೂಸ್ಟ್ ಆಗುತ್ತೆ. ಟ್ರೈ ದಿಸ್ ಕಾನ್ಸೆಪ್ಟ್. ಓಕೆ, ನಾನು ಹಾಗೆ ಮಾಡ್ತಿದ್ದೆ ಆಕ್ಚುಲಿ. ಯಾವ್ಯಾವ ಈಸಿ ಟಾಪಿಕ್ಸ್ ಅದಲ್ಲ, ಫಸ್ಟ್ ಐ ಯೂಸ್ ಟು ಲರ್ನ್ ಆಲ್ ದೋಸ್ ಈಸಿ ಟಾಪಿಕ್ಸ್. ಆಮೇಲೆ ಸ್ವಲ್ಪ ಎನರ್ಜಿ ಬೂಸ್ಟ್ ಆಗಿತ್ತು. ಎಸ್, ನಾನೆಲ್ಲ ಚಾಪ್ಟರ್ಸ್ ಓದಿದೆ, ಆಲ್ಮೋಸ್ಟ್ 4 ಚಾಪ್ಟರ್ಸ್ ಮುಗಿತು ನಮ್ದು ಈಸಿ ಚಾಪ್ಟರ್ಸು, ನಾನೀಗ ಡಿಫಿಕಲ್ಟ್ ಚಾಪ್ಟರ್ಸ್ಗೆ ಹೋಗ್ತೇನೆ. ದ್ಯಾಟ್ ಶುಡ್ ಬಿ ದ ಎನರ್ಜಿ. ಅಂಡರ್ಸ್ಟುಡ್? Next, carbon atoms with 3 atoms will be present. Then general term is going to be the triose. It is going to be general term what? Triose. Clear? Triose. I'll write it down with the black if it's not visible properly. Carbon atoms 3 ಇದ್ರೆ ಅದಕ್ಕೆ triose ಅಂತ ಕರೀತಾರೆ. Clear? And aldehyde is going to be what? Aldehyde ಮತ್ತೆ ketone aldotriose. Okay, aldotriose. And comes what? Ketotriose. Next comes the ketotriose. So same ಅದೇ ತರ 4 ಇದ್ರೆ tetrose, aldotetrose and ketotetrose. Then next afterwards again 5 ಆ ಕಾರ್ಬನ್ ಆಟಮ್ ಇದ್ರೆ pentose ಅಂತ ಕರೀತಾರೆ. 5 means pentose. 5 means pentose. Clear? So 5 means pentose and it is also called as aldopentose and ketopentose. Means prefix nalli ketose madhe aldose anta haakbedi. Simple. It will be understandable. Okay. Next comes 6 hexose, aldohexose, ketohexose. In case carbon atoms 7 idre 7 idre heptose and aldoheptose and ketoheptose. This is how you are going to name the things according to the carbon atoms. Eshtappa number of carbon atoms ide alla adar prakara you people can answer this questions. Done. Next, oligosaccharides. So let's move to the oligosaccharides. Understood till here, everyone? Clear tidena? Understanding? Yes. Oligosaccharides andre enu? These are the sugars which yield 2 to 10 monosaccharides units on hydrolysis. On hydrolysis, it will actually yield. Okay, in yield madutte on hydrolysis, it will yield almost 2 to 10 monosaccharide units. It will yield 2 to 10 monosaccharide units. Clear? And on hydrolysis. Edrinda agutte on hydrolysis. So these are the sugars which yield 2 to 10 monosaccharide units on hydrolysis. Hydrolysis adaga avu almost to yield agutte 2 to 10 monosaccharides. That is actually called as oligosaccharides. Clear up? Oligosaccharides andre enu? 2 to 10 monosaccharides will be units will be yield to by hydrolysis. By hydrolysis is called as oligosaccharides. Clear? Next, when 2 monosaccharides units obtained. So when 2 monosaccharides obtains on hydrolysis of dischardyl, they may be same or different. Like example sucrose in the presence of hydrolysis. Sucrose on the presence of hydrolysis, glucose plus fructose is being produced. Okay, glucose plus fructose is being produced. Clear? Sucrose in the presence of hydrolysis, glucose ಮತ್ತೆ fructose produce ಮಾಡುತ್ತೆ. ನೀವು ಯಾವಾಗ ಅದನ್ನ hydrolyze ಮಾಡ್ತಾರಲ್ಲ, simple 2 things will be present. Glucose ಮತ್ತೆ fructose. So ಇವೆರಡು ಎಲ್ಲಿದೆ ಅನ್ನೋದು fast chat box ನಲ್ಲಿ ಹಾಕಿ. Let's see. ಎಲ್ಲಿದೆ ಇವೆರಡು? Where it is present? Come on. ಯಾವುದ್ರಲ್ಲಿ ಇದೆ ಗ್ಲೂಕೋಸ್ ಮತ್ತೆ ಫ್ರುಕ್ಟೋಸ್? ಫಾಸ್ಟ್ ಆಗಿ ಚಾಟ್ ಬಾಕ್ಸ್ ನಲ್ಲಿ ಹಾಕಿ. ಫಾಸ್ಟ್ ಆಗಿ ಆಯ್ತಾ? Next comes the dischardyls. What is the meaning of an dischardyls? Okay. Now 2 monosaccharide units on hydrolysis. 2 monosaccharides unit ಇದೆ. Hydrolyze ಆಗ್ತಿದೆ. Okay. Hydrolyze ಆಗ್ತಿದೆ. May or may not be same. By example, sucrose ಮತ್ತೆ maltose. Sucrose ಮತ್ತೆ maltose. So 2 monosaccharide units will get hydrolyzed, sometimes may, sometimes not. So those are called as disaccharides. That is also called as sucrose or a maltose as a simple example. Clear? Next comes the trisaccharides. So what is the meaning of a trisaccharides? 3 monosaccharide unit on hydrolysis. 3 monosaccharide units. Tri andre 3. Tri andre 3. Di andre 2. Okay, ಆ ತರ ನೆನಪಿಟ್ಕೋಬಹುದು. Di andre 2. 2 monosaccharide units. So tri andre 3. 3 monosaccharide units. Sorry. Tri andre 3. 3 monosaccharide units. So ಆ ತರ ನೀವು ನೆನಪಿಟ್ಕೋಬಹುದು. Okay? Examples ಏನು ತಗೋಬಹುದು? What examples people can take? Any trisaccharides units you can take that as an example. Clear? Next comes the polysaccharides. What is the meaning of a polysaccharides? Poly andre ಜಾಸ್ತಿ, 3 4 ಕಿಂತ ಜಾಸ್ತಿ ಇರೋದೆಲ್ಲ polysaccharides ಅಂತ ಕರೀತಾರೆ. Right? Let us check it out. These are the non-sugars which yield a large number of monosaccharide units. Means what? More than 3 units if it is producing, they are all called as polysaccharides. Clear? And on hydrolysis, and polysaccharides are the carbohydrates which on hydrolysis will yield a large number of monosaccharide units. Clear? So large number of monosaccharide units will be produced. Clear? Then polysaccharides are not sweet in taste. So polysaccharides sweet illa. So ba kadu ide. ನಿಮ್ ಸ್ವಲ್ಪ ಮಂದಿ ಇರ್ತಾರಲ್ಲ, ದೇ ವಿಲ್ ನಾಟ್ ಬಿ ಸ್ವೀಟ್ ಇಟ್ ಸೆಲ್ಫ್. ಸೊ ಅದೇ ತರ. ಓಕೆ, ಸೊ ಇದು ಅಷ್ಟು ಸ್ವೀಟ್ ಇರಲ್ಲ ಅಂದ್ರೆ ಅದಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ಬೋದು. ನೀವು ನೋಡ್ಬೋದಾ, ಶುಗರ್ ಫ್ರೀ ಐಸ್ ಕ್ರೀಮ್, ಶುಗರ್ ಫ್ರೀ ಅದೇನೋ ಬರುತ್ತಲ್ಲ, ಯಾವುದೋ ಒಂದು ಶುಗರ್ ಫ್ರೀ ಸ್ವೀಟ್ನರ್ ತರ ಇರುತ್ತೆ. ಇಟ್ ಇಸ್ ಆಕ್ಚುಲಿ ಲೆಮನ್, ಐ ಡೋಂಟ್ ನೋ ದ ನೇಮ್ ಆಫ್ ದಟ್ ರೈಟ್ ನೌ. ಲೆಮನ್ ಯೆಲ್ಲೋ ಕಲರ್ ಇರುತ್ತೆ ಆಕ್ಚುಲಿ ಬಾಕ್ಸು. ಸೊ ಅದನ್ನ ತಗೊಂಡು ಚಾನಲ್ಲಿ ಕಾಫಿನಲ್ಲಿ ಹಾಕ್ತಾರಲ್ಲ. New trend is actually no one should have a sweet, but I can't survive without this sweet. Right? ಯಾರ್ಯಾರಿಗೆ ಸ್ವೀಟ್ಸ್ ಇರುತ್ತೆ ಫಾಸ್ಟ್ ಆಗಿ ಹೇಳಿ ನೋಡೋಣ. Let's see how many people like the sweets. So polysaccharides are not sweet in taste, hence they are also called as non-sugars. Polysaccharides again non-sugars antanu karitare because they are actually not in a taste only. Okay, they don't have a taste itself. They don't have a taste itself. Clear? Next comes general formula C6H10O5N. So C6H10O5N is the general formula for the polysaccharides. Clear? Next comes starch, cellulose and the glycogen is also called as a polysaccharides. Means what? ಈ starch, cellulose, glycogen ನಲ್ಲಿ ಜಾಸ್ತಿ monosaccharide units ಇರುತ್ತೆ. ಜಾಸ್ತಿ monosaccharide units ಇರುತ್ತೆ. ಅವಕ್ಕೆಲ್ಲ ಏನ್ ಕರೀತಾರೆ? Polysaccharides ಅಂತ ಕರೀತಾರೆ. Clear everyone till here? Done? Done? Understood? Understand ಆಗ್ತಿದೆನಾ? Understanding, guys? Understanding? Yes, let's move to the next part. Reducing and non-reducing sugars. What is the meaning of reducing and non-reducing sugar? Those sugars or carbohydrates which reduce Felling's solution and Tolle's reagent are referred to as an reducing sugar. Clear? So those sugars, yav sugar idella, avella, or it is also carbohydrates also. Sugars discuss madidvi navu matte carbohydrates discuss madidvi. Eradu tara heltidene. Carbohydrates irli akasmat sugar irli which reduce the Felling's solution. ಏನ್ ಮಾಡುತ್ತದು? ರೆಡ್ಯೂಸ್ ಮಾಡುತ್ತೆ Felling's solution ಮತ್ತೆ Tolle's reagent ಅನ್ನ. Felling's solution and Tolle's reagent ಅನ್ನ reduce ಮಾಡ್ತಾರಲ್ಲ ಅವಕ್ಕೆಲ್ಲ ಏನ್ ಕರೀತಾರೆ? Reduced sugar. Those all are referred as reduced sugar. This much remember. Now all monosaccharides, whether aldose or ketos, are reducing sugars itself. Why? Because tell me why. Monosaccharides ಯಾವ್ಯಾವ ಅದಾವಲ್ಲ ಆಲ್ಮೋಸ್ಟ್ ಆಲ್ ಮೊನೋಸ್ಯಾಕರೈಡ್ಸ್ ಅಂದ್ರೆ ನಾವು ಎರಡೇ ಕಲ್ತಿರೋದು ಅಲ್ಡೋಸ್ ಮತ್ತೆ ಕೀಟೋಸ್ ಆ ಎರಡಕ್ಕೂ ಏನ್ ಕರೀತಾರೆ ರೆಡ್ಯೂಸಿಂಗ್ ಶುಗರ್ಸ್ ಅಂತ ಕರೀತಾರೆ. Why the things will get reduced? Because of what? Because of the reagent. That's what I told, right? In this disaccharides, when the reducing groups of the monosaccharides, that is aldehydic or ketonic groups, and are being bonded, and these are referred as an non-reducing sugars. Okay, you all non-reducing sugars. Okay, example sucrose antanu ತಗೋಬಹುದು. So disaccharides ನಲ್ಲಿ ಏನು ಆಗುತ್ತಂದ್ರೆ when the reducing groups of monosaccharides ಇಂದ ಏನು reduce ಆಗ್ತಿರುತ್ತಲ್ಲ ಯಾವವು actually aldehydic ಮತ್ತೆ ketonic groups ಇರುತ್ತೆ. Okay, aldehydic ಮತ್ತೆ ketonic groups are present in the disaccharides and they all are not called as a non-reducing, they are all called as a non-reducing sugars. Example sucrose. Okay, example sucrose which you people eat sugar cane bartala, cane sugar, that is all we will eat, right? Ellaru tintare sugar. Yaar sugar tinnalla nodona heli? Who will not eat sugar? Who don't like sugar only? Who don't like sugar? I at least love sugar. Sugar irlilla andre dinane mugiyalla, right? You can see, we know, understand. Right? Next comes the glucose. So what is the meaning of an glucose now? Let us learn about it. Glucose ಅಂತ ಲೈಫ್ ಇಡೀ ಕೇಳಿರ್ತಾರ ಏನಪ್ಪ ಗ್ಲೂಕೋಸ್ ಅನ್ನೋದು ಸ್ವಲ್ಪ ಮಂದಿಗೆ ಅಂತೂ ಗೊತ್ತಿರುತ್ತೆ. But how actually it works and how it has been produced, those things we will discuss. ಆಯ್ತಾ? Glucose occurs in both free and combined forms in nature. So glucose will occur in what? Glucose will occur in both. Free ನಲ್ಲಿ ಇರುತ್ತೆ, combined form of the nature ನಲ್ಲೂ ಇರುತ್ತೆ. Free form ಅಂದ್ರೆ ಏನು? Means what? ಇದು ಗ್ಲೂಕೋಸು ಸಪ್ರೇಟ್ ಆಗಿನೂ ಇರುತ್ತೆ. ಇಟ್ಸ್ ಲೈಕ್ ಅಲೋನ್ ಆಲ್ಸೋ ಇಟ್ ಕ್ಯಾನ್ ಸ್ಟೇ ಅಂಡ್ ಇಟ್ ಕ್ಯಾನ್ ಸ್ಟೇ ವಿತ್ ದ ಫ್ರೆಂಡ್ಸ್ ಆಲ್ಸೋ. ಓಕೆ, ಫ್ರೆಂಡ್ಸ್ ಆಲ್ಸೋ ಮೀನ್ಸ್ ವಾಟ್? ಇಟ್ ವಿಲ್ ಬಾಂಡ್ ವಿತ್ ಅದರ್ಸ್ ಆಲ್ಸೋ ವೆರಿ ನೈಸ್ಲಿ. ಇಟ್ಸ್ ನಾಟ್ ಲೈಕ್ ಐ ವಿಲ್ ನಾಟ್ ಬಾಂಡ್ ಓನ್ಲಿ, ಇಟ್ ವಿಲ್ ಬಾಂಡ್ ಆಲ್ಸೋ ವಿತ್ ದ ಅದರ್ ಥಿಂಗ್ಸ್ nicely. Okay, it is present in honey, and sweet fruits. It's present in honey and sweet fruits. Clear? Now, also glucose is present in large amounts in ripe grapes. So ripe grapes nalli ಅದಕ್ಕೆ ಹೇಳ್ತಾರಲ್ಲ ಯಾರು weight gain ಮಾಡೋದಿದೆಯಲ್ಲ, those weight gain students will ಯಾರಿಗೆ weight gain ಮಾಡೋದಿರುತ್ತಲ್ಲ ಅವ್ರ weight gain ದವರಿಗೆ actually ripes ಭಾಳ ತಿನ್ನಂತಾರೆ. ಡ್ರೈ ಗ್ರೇಪ್ಸು, ಗೋಡಂಬಿ ಅನ್ನೆಲ್ಲ ತಿನ್ಲಿಕ್ಕೆ ಹೇಳ್ತಾರೆ. ಹೂ ವಾಂಟ್ಸ್ ಟು ಗೇನ್ ದ ವೇಟ್? ವೈ? ಬಿಕಾಸ್ ಇಟ್ ಹ್ಯಾಸ್ ಅ ಗುಡ್ ಅಮೌಂಟ್ ಆಫ್ ಅ ಶುಗರ್. ಅದು ನ್ಯಾಚುರಲ್ ಶುಗರ್ ಇರುತ್ತೆ. ಅದು ಇಟ್ಸ್ ನಾಟ್ ಲೈಕ್ ಆರ್ಟಿಫಿಷಿಯಲ್ ಶುಗರ್ ಹ್ಯಾಸ್ ಬೀನ್ ಆಡೆಡ್. ಇಟ್ಸ್ ಅ ನ್ಯಾಚುರಲ್ ಶುಗರ್ ಇಟ್ ಸೆಲ್ಫ್. ಸೊ ದೇ ವಿಲ್ ಟೆಲ್ ಲೈಕ್ ಈಟ್ ದ ನ್ಯಾಚುರಲ್ ಥಿಂಗ್ಸ್ ಅಂಡ್ ಬಿಕಮ್ ನ್ಯಾಚುರಲಿ ಫ್ಯಾಟ್. ಇಟ್ಸ್ ನಾಟ್ ಲೈಕ್ ಏನೋ ಒಂದು ಕೆಮಿಕಲ್ಸ್ ತಗೊಂಡು ಏನೋ ಒಂದು ಮಾಡ್ಕೊಂಡು ಸಣ್ಣ ಆಗ್ತೇನಪ್ಪ ನಾನು ದಪ್ಪ ಆಗ್ತೇನೆ ಅಂದ್ರೆ ಆ ವರ್ಕ್ ಆಗಲ್ಲ. ತಿಳಿತಾ? And next, it is also known as grape sugar. That's what I told you. Natural sugar. That is grape sugar. Okay. Next, glucose is the unit of starch, cellulose, and glycogens. It is also a unit of what? Starch, cellulose, and glycogens. Okay. And glycogens. Remember this. This is also very important about the glucose. Clear? Next comes preparation of a glucose. Now in the preparation we will be learning according, means ಏನ್ ಗ್ಲೂಕೋಸ್ ಮಾಡ್ತೇವಲ್ಲ, ಏನ್ ತಗೊಂಡು ಗ್ಲೂಕೋಸ್ ಪ್ರಿಪೇರ್ ಮಾಡ್ತೇವೆ ಅದರ ಪ್ರಕಾರ ನಾವು ಪ್ರಿಪರೇಷನ್ ಮಾಡ್ಕೊಳ್ಳೋಣ. ಆಯ್ತಾ? ಫಸ್ಟ್ ಒನ್ ಏನಿದೆ? ಫ್ರಮ್ ದ ಸುಕ್ರೋಸ್, ಫ್ರಮ್ ದ ಸ್ಟಾರ್ಚ್ and structure of the glucose is also there, and reaction of the glucose is also there. Okay, we'll learn everything. Wait. Yes. Now preparation of a glucose, let us start. So glucose andre ena gottayitu. Glucose units are what? Starch, cellulose, and glycosides, right? So ivella glucose du units. Now from sucrose, how can we prepare a glucose? Clear? From sucrose, how can we prepare a glucose? Concentrate. These all things are very important, guys. Important. So important ಇವೆಲ್ಲ ಕಾನ್ಸೆಪ್ಟ್ಸು ಮಿಸ್ ಮಾಡಬೇಡಿ. ತೀತಾ? ಮಿಸ್ ಮಾಡಬೇಡಿ. Yes. From sucrose, let's start. Fructose and glucose are obtained in equal amounts. Fructose and glucose are obtained in the equal amount. But when the sucrose is boiled with dilute HCl, whenever the sucrose has been boiled with the dilute HCl or H2SO4, okay? ಯಾವಾಗ ನಾವು ಸುಕ್ರೋಸ್ ಅನ್ನ ಎದ್ರ ಜೊತೆ ಬಾಯ್ಲ್ ಮಾಡ್ತೇವೆ? We are boiling with dilute HCl and H2SO4. HCl ತಗೊಳ್ಳಿ, H2SO4 ತಗೊಳ್ಳಿ, but in the form of a dilute way, okay? And in an alcoholic solution. In an alcoholic solution, we will get glucose plus fructose. We will get what? Glucose plus fructose. Clear? From sucrose, fructose and glucose are obtained in the equal amount when sucrose is being boiled. Okay, when sucrose is being boiled, we will get equal amount of fructose also, we'll get equal amount of glucose also. Clear? So I'll note fructose ide, glucose ide, equal amount ನಲ್ಲಿ ಸಿಗುತ್ತೆ ಅದು ಬಿ, equal amount ನಲ್ಲಿ. ಬಟ್ ನಾವು ಗ್ಲೂಕೋಸ್ ಅಂತ ಕನ್ಫ್ಯೂಸ್ ಎದಕ್ಕೆ ಮಾಡ್ಕೋತೇವೆ? C6H12O6 ಅಂದ್ರೆ ಗ್ಲೂಕೋಸ್ ಅಪ್ಪ. Okay, glucose ಎದಕ್ಕೆ ಬರುತ್ತೆ? Even though photosynthesis process is happening, glucose we will get it, right? So glucose ಮತ್ತೆ ಫ್ರಕ್ಟೋಸ್ ಎರಡು ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡುತ್ತೆ. ಯಾವಾಗ? ಸುಕ್ರೋಸ್ ಅನ್ನ, ಯಾವಾಗ ನಾವು ಸುಕ್ರೋಸ್ ತಗೊಂಡಿದ್ದೆ, ಎಲ್ಲಿದೆ ಸುಕ್ರೋಸ್? ಓಕೆ, ವೆನ್ ಸುಕ್ರೋಸ್ we will take it and boil ಮಾಡ್ತೇವೆ ಡೈಲ್ಯೂಟ್ HCl ಜೊತೆ ಮತ್ತೆ H2SO4 ಜೊತೆ ಏನು ಡೈಲ್ಯೂಟ್ ಮಾಡ್ತೇವಲ್ಲ ಅವಾಗ ಅದು ಆಗುತ್ತೆ. ಕ್ಲಿಯರ್ ಎವ್ರಿವನ್? ಅಂಡರ್ಸ್ಟುಡ್? ಈ ರಿಯಾಕ್ಷನ್ಸ್ ಅನ್ನ ನೆನಪಿಟ್ಕೋಬೇಕು. ಸುಕ್ರೋಸ್ ಅಂದ್ರೆ C12VH22O11 ಅಂತ ನೆನಪಿಟ್ಕೋಬೇಕು. ಗ್ಲೂಕೋಸ್ ಅಂದ್ರೆ C6H12O6 ಅಂತ ನೆನಪಿಟ್ಕೋಬೇಕು. ಈ ತರ ಇವನ್ನೆಲ್ಲ ನೀವು ನೆನಪಿಟ್ಕೋಬೇಕು. ಎಷ್ಟು ಕಾರ್ಬನ್ ಆಟಮ್ಸ್ ಇದೆ, ಹೈಡ್ರೋಜನ್ ಆಟಮ್ಸ್ ಎಷ್ಟಿದೆ, ಆಕ್ಸಿಜನ್ ಆಟಮ್ಸ್ ಎಷ್ಟಿದೆ, ಇವನ್ನೆಲ್ಲ ಇಂಪಾರ್ಟೆಂಟು. ಸೊ ಅದಕ್ಕೆ ಸ್ಟ್ರೆಸ್ ಮಾಡಿ ಮಾಡಿ ಹೇಳ್ತಿದ್ದೇನೆ ಅದನ್ನ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಕಮ್ಸ್ ಫ್ರಮ್ ಸ್ಟಾರ್ಚ್. ಸೊ ಫ್ರಮ್ ಸುಕ್ರೋಸ್ ಇಸ್ ಕ್ಲಿಯರ್? Clear everyone from the sucrose? Am I fast little? I'll reduce it. I'll reduce it little bit. I'll reduce it little. One second, guys. Shall I reduce it little bit? Okay, we'll go little slower. Okay, From starch, glucose is obtained commercially by the hydrolysis of starch by boiling. Okay, starch and tagondvi. We have taken a starch. We have taken starch and we started boiling it at 393 Kelvin. Starch tagondvi. We are heating or we are boiling it at 393 Kelvin. Clear? So, avage agatte hydrolysis aglik start agutte with dilute H2SO4. With dilute H2SO4. So, how the glucose has been obtained? When we are going to commercially hydrolyze. Commercially hydrolyze ಮಾಡುತ್ತೆ. ಏನು hydrolyze ಮಾಡ್ತೇವೆ? We are going to hydrolyze the starch. Starch ತಗೋಣ, hydrolyze ಮಾಡೋಣ. We will boil it at 393 Kelvin with the help of dilute H2SO4. Then we will get a glucose. We will get what? Glucose. Clear? Understood how the glucose has been formed? To just the balance the equation, they are written it has N in yadakeda just to balance the equation. Clear? C6H12O5, that is a starch, or it is also called as a cellulose also. You know already starch andre eno cellulose anta enannadu before previous chapters nalli already kaltirtera. Okay, then it is reacting with H2O in the presence of H plus, and means hydrolyze ಆಗ್ತಿದೆ ಅಂದ್ರೆ H plus ಬೇಕಲ್ಲ. Hydrolyze becoming is H plus necessity, right? At a temperature of 293 Kelvin and 2 to 3 atm pressure, means pressure 2 to 3 pressure means obviously now temperature ಹಾಕ್ತಿದೆ ಅಂದ್ರೆ pressure apply ಆಗೇ ಆಗುತ್ತೆ. So that is going to get as glucose. Clear? Then we are going to get it as glucose. Clear? Done? Next, structure of glucose. Let's learn about the structure of a glucose. One second, guys. Yes, sorry. Structure of glucose. So glucose is aldohexose and is also called as dextrose. Okay, it is also known as what? Dextrose, or it is also called as dextrose. I don't know how to pronounce, but dextrose anta karbidoಣ ಆಯ್ತಾ. So structure of glucose ಹೇಗಿದೆಯಪ್ಪ? Glucose is a aldohexose. ಏನಿದೆ ಇದು? Glucose is actually a aldohexose and also it is called as a dextrose. Clear? And glucose is a monomer of the many of the larger carbohydrates, namely cellulose and a starch. Okay, glucose is like how you know it's glucose is handling two families. I can tell you simple way andre. Okay, glucose so starch family anna ಮತ್ತೆ cellulose family ಅನ್ನನ್ನು ನೋಡ್ಕೋತಿದೆ. Like example ಇರುತ್ತಲ್ಲ, ದೊಡ್ಡಪ್ಪ ಇರ್ತಾರಲ್ಲ, ದೊಡ್ಡಪ್ಪ. ಸೊ ದೊಡ್ಡಪ್ಪ ಕಾಕ ಮತ್ತೆ ಅವ್ರಕ್ಕಿಂತ ಸಣ್ಣವ್ರು ಯಾರು ಚಿಕ್ಕವ್ರು ಇರ್ತಾರಲ್ಲ ಕಾಕ, ಅವ್ರ ಕಾಕಗಳು ನೋಡ್ಕೊತಿರ್ತಾರಲ್ಲ. ಲೈಕ್ ಎಕ್ಸಾಂಪಲ್ ಏನೋ ದೊಡ್ಡಪ್ಪ ಇದಾನೆ, ಏನಾದ್ರು ಒಂದು ಹೊಲ ಇದ್ರೆ ಒಂದು 50 ಎಕರೆ ಹೊಲ ಆಯ್ತಪ್ಪ. ಸೊ ಈ ಕಾಕನೂ ಏನ್ ಅಂದ್ರೆ ಇವ್ ದೊಡ್ಡಪ್ಪನೇ ಕುಂತ ಹೊಲ ನೋಡೋದು, ಈ ಕಾಕಗಳು ಬೇರೆ ಕೆಲಸ ಮಾಡ್ತಾರೆ. ಸೊ ಅದನ್ನ ಜಸ್ಟ್ ನೋಡ್ಕೊಳ್ಳೋದು. ದೇರ್ ಫ್ಯಾಮಿಲೀಸ್ he will take care like a big family, like a joint family. Okay, ಆ ತರ ಅಂತ ಗ್ಲೂಕೋಸ್ ಅನ್ನ ಕರಿಬಹುದು ಆಯ್ತಾ. Now it is considered to be the present in the large amounts as an organic compound on earth. Okay, it is considered to be a present in the larger amount in the organic compounds on earth. So that is going to be what? C6H12O6 is its molecular formula, like CHO, CHOH4, CH2OH. This is also called as a glucose. This is a structure of a glucose which is very, very, very important. Okay, important. ಅದು ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಸಿ ಸಣ್ಣ ಹುಡುಗರಂಗೆ ನಾ 10ನೇ ಹುಡುಗರು ಕಲ್ಸೋರಂಗೆ ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಅಂತ ಹೇಳ್ತಿದ್ದೇನೆ. ಯಾಕಪ್ಪ ಕುಂತ ಅದನ್ನ ಓದಿ ಜಾಸ್ತಿ ಸಲ ಬುಕ್ ಮುಂದಿಟ್ಕೊಂಡು ಬರೀರೋದನ್ನ ಕುಂತ ನಾನು ಮ್ಯಾಮ್ ಆ ಹುಡುಗಿ ಏನು ಮಾಡ್ಲು, ಈ ಹುಡುಗಿ ಏನು ಮಾಡಿದ್ಲು, ಆಗ ಏನು ಮೆಸೇಜ್ ಮಾಡಲಿ, ಇವ್ರಿಗೆ ಏನು ಮೆಸೇಜ್ ಮಾಡಲಿ, ಅದನ್ನೆಲ್ಲ ಬಿಡಿ. ಏನು ಕಲಿಸ್ತಿರ್ತೇನಲ್ಲ, ಕಲ್ಸೋದ್ ಮುಂದೆನೇ ನೋಟ್ ಮಾಡ್ಕೊಂತ ಹೋಗಿ. ಇಟ್ ವಿಲ್ ಹೆಲ್ಪ್. ಅಟ್ ಲೀಸ್ಟ್ ಇಟ್ ವಿಲ್ ಬಿ ನಾಟ್ ಲೈಕ್ ಯು ಆರ್ ವೇಸ್ಟಿಂಗ್ ಯುವರ್ ಟೈಮ್. ಓಕೆ, ವೇಸ್ಟ್ ಮಾಡೋ ಟೈಮ್ ಅಂತ ಅನ್ಕೊಳ್ಳೋಕ್ಕಾಗಿಲ್ಲ ಆಯ್ತಾ. So C6H12O6 is its molecular formula, that is CHO, CHOH4 and CH2OH. That is called as a glucose. Done. Next comes the reaction of a glucose. Where first we are going to learn about the oxidation. Now dicarboxy acid, and even it is also called as what? Saccharic acid can be yielded by oxidizing both glucose as well as gluconic acid with the nitric acid. Clear? So dicarboxylic acid ಏನಿದೆ ಅಲ್ಲ ಆಕ್ಸಿಡೇಷನ್ ಹೇಗಾಗುತ್ತೆ ಓಕೆ ಆಕ್ಸಿಡೇಷನ್ ಹೇಗಾಗುತ್ತೆ ಗ್ಲೂಕೋಸ್ ನಲ್ಲಿ ಸೊ dicarboxylic acid which is present that a saturic acid both dicarbolic acid and saturic acid can be yield ಆಗುತ್ತೆ by oxidizing both the glucose as well as glycolic acid ಯಾವಾಗ ಇದನ್ನ yield ಆಗುತ್ತೆ ಸಾರಿ ಆಕ್ಸಿಡೈಸ್ ಆಗುತ್ತೆ ಯಾವಾಗ ಗ್ಲೂಕೋಸ್ ಮತ್ತೆ ಗ್ಲೈಕಾನಿಕ್ ಆಸಿಡ್ ಏನಿದೆ ಅಲ್ಲ ಇಟ್ ವಿಲ್ ಗೆಟ್ ಇಟ್ ಅಪ್ ವಿತ್ ದ ನೈಟ್ರಿಕ್ ಆಸಿಡ್ clear? Next, this indicates the presence of the primary alcohol. So idna preparation ಮಾಡ್ತಿರಲ್ಲ we will even get the primary alcohol group also, that is OH in the glucose. OH nu barutte in the glucose. Clear? You can check here OH is present only. Okay, next, so let's check it out how it's been possible. This is guys very important. ಮತ್ತೆ PU board ನಲ್ಲಿ short question ಇದು. Short question is the PU board nalli. It's a short question for the PU mode. See, check it out. CHOH4, CH2OH, which is a glucose here, which is a glucose. You know already how the glucose is there. 1, 2, 3 carbons are present. 2, 3, 4 hydrogens are present. Sorry, here full things are present here. As a C6H12O6. So this will be the structure of it. Okay. Now, by Felling's solution ಏನಾಗುತ್ತೆ? By Tollens reagent ಏನಾಗುತ್ತೆ? By concentrated HNO3 ಏನಾಗುತ್ತೆ? By Br2 water ಇಂದ ಏನಾಗುತ್ತೆ? Now, when it will get oxidized also, what is the reaction forming? Those are all things I'll explain it now. Okay. Concentrate properly. ತಿಳಿದು ಎಲ್ಲ ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡಿದ್ರೇ ಅಷ್ಟೇ ತಿಳಿಯೋದು. ಸೊ ವೆನ್ ಗ್ಲೂಕೋಸ್ ವಿತ್ ದ ಹೆಲ್ಪ್ ಆಫ್ ದ ಫಿಲ್ಲಿಂಗ್ ಸೊಲ್ಯೂಷನ್, ಯಾವಾಗ ಫಿಲ್ಲಿಂಗ್ ಸೊಲ್ಯೂಷನ್ ಜೊತೆ ಹೈಡ್ರೋಲೈಸ್ ಆಗುತ್ತಲ್ಲ ಅವಾಗ CHOH4 ಮೀನ್ಸ್ ಈ ಪಾರ್ಟ್ ಏನಿದೆ ಅಲ್ಲ ಇಟ್ ವಿಲ್ ರಿಮೇನ್ ಹಿಯರ್ ಇಟ್ ಸೆಲ್ಫ್. ಓಕೆ, ನಥಿಂಗ್ ವಿಲ್ ಬಿ ಚೇಂಜ್ ಇಟ್ ದೇರ್. ದಿಸ್ ಪಾರ್ಟ್ ವಿಲ್ ಬಿ ರಿಮೇನ್ ಹಿಯರ್ ಇಟ್ ಸೆಲ್ಫ್ ಬಿಕಾಸ್ ಆಫ್ ದ ಫಿಲ್ಲಿಂಗ್ ಸೊಲ್ಯೂಷನ್ ಇಟ್ ವಿಲ್ ಬಿ ಬಿಕಮಿಂಗ್ COOH. ಓಕೆ, COOH ಫಿಲ್ಲಿಂಗ್ ಸೊಲ್ಯೂಷನ್ ಅಂದ್ರೆ ನೆನಪಿಟ್ಕೊಳ್ಳಿ, ಫಸ್ಟ್ ಬರೋದು COH, ಆಮೇಲೆ ಗ್ಲೂಕೋಸ್ ಬರೋದು. ಏನ್ ಗ್ಲೂಕೋಸ್ದು? ಗ್ಲೂಕೋಸ್ ಸೇಮ್ ತರ CHOH4. ಓಕೆ, CHOH4. ಡನ್. Then the remaining things will be same itself. Understood? Plus Cu2O, that is actually a red PPT. Cu2O, copper ನಿಮಗೆ ಗೊತ್ತಿದೆಯಲ್ಲ ಹೇಗೆ ಫಾರ್ಮ್ ಆಗುತ್ತೆ ಅನ್ನೋದು. Sometimes actually it will form green color also, but most probably if filling solutions will be added, it will be red PPT itself, but sometimes some reactions will be green also. Okay, next comes the Tollens reagent. With the help of Tollens reagent, how it's been done? COH, CHOH4, CH2OH, same ಅದೇ ತರ ಎಲ್ಲ. Just the thing is we will get it the side product as Ag, that is silver mirror. Okay, it is also called as a silver mirror. Ag ಅಂದ್ರೆ ನಿಮಗೆ ಗೊತ್ತಿದೆ ಆಲ್ರೆಡಿ, silver ಅಂತ. Clear? Done? Clear? Next comes concentrated HNO3. Okay, concentrated HNO3 ಹಾಕಿದ್ರೆ ಏನಾಗುತ್ತಪ್ಪ? With that CHOH, same ಅದೇ ತರ CH2OH, that is going to be the glycolic acid. Clear? Glycolic acid. If in case it has a COOH and remaining things will be same as a glucose itself. Clear? Remaining things will be as it is of a glucose itself. Clear? In the presence of Br2 and water, okay, Br2 ಮತ್ತೆ H2O. Okay, Br2 ಮತ್ತೆ H2O ಇದ್ರೆ ಎಲ್ಲ everything will be same itself. CH2OH ಇರುತ್ತೆ. This is called as glycolic acid itself. Okay, it is also called as glycolic acid itself. Now what you need to remember, now glucose, when it is with the filling solutions, we are going to get the side product as Cu2O. That is going to be what? Red PPT, or sometimes green also. Next, with the Tollens reagent, everything will be same, just the upper end will be changed, that is COH ಇರುತ್ತೆ. ಮತ್ತೆ Ag, that is silver, will be produced. Clear? Silver mirror will be produced. Now with the Br2 and water, and with the help of concentrated HNO3, we are going to get a same product, that is going to be glycolic acid. ಏನ್ ಸಿಗುತ್ತೆ ಪ್ರಾಡಕ್ಟ್? Glycolic acid ಅಂತ ಸಿಗುತ್ತೆ. Now let's come to oxidization, how it's getting oxidized. Okay, ಈಗ full glucose ತಗೊಂಡಿದ್ದೇವೆ. We have taken the glucose, we are oxidizing it. We are getting it oxidized. What we are going to get the product? COOH, that is also called as sacharic acid also. CHOH4 and COOH. Clear? Sacharic acid andre ಏನ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ? ಸೇಮ್ ಗ್ಲೈಕಾನಿಕ್ ಆಸಿಡ್ ತರಾನೇ, ಬಟ್ ಡೌನ್ ಗ್ರೂಪ್ ಏನಿರುತ್ತಲ್ಲ, CH2OH ಏನಿರುತ್ತಲ್ಲ, ಇಟ್ ವಿಲ್ ಬಿ ರಿಮೂವ್ಡ್. ಮೀನ್ಸ್ ನಮ್ ಈಸಿ ವೇ ಆಗಿ ನೆನಪಿಟ್ಕೊಳ್ಳಿಕ್ಕೆ ಹೇಳ್ತಿದ್ದೇನೆ. ಇಟ್ ವಿಲ್ ಬಿ ರಿಮೂವ್ಡ್ and it will be formed what? COOH. It will be formed what? COOH. This much remember enough. That is called as what? Sacharic acid. That is called as what? Sacharic acid. Now, by oxidation again, if you are going to oxidize it again, that's what. If you are going to oxidize again, we are going to glycolic acid. ತಿಳ್ಕೊಳ್ಳಿ, ಈಗ ಅಕಸ್ಮಾತ್ ಓಕೆ ಗ್ಲೂಕೋಸ್ ಅನ್ನು ಆಕ್ಸಿಡೈಸ್ ಮಾಡಿದ್ರೇನು ಸೈಚೋಲಿಕ್ ಆಸಿಡ್ ಅನ್ನೇ ಸಿಗುತ್ತೆ. ಇಫ್ ಯು ಟೇಕಿಂಗ್ ಗ್ಲೈಕಾನಿಕ್ ಆಸಿಡ್ ಆಲ್ಸೋ, ಲೈಕ್ ಎಕ್ಸಾಂಪಲ್ ಇಲ್ಲಿ ಬರ್ದಿದ್ದಾರೆ, we have taken a glycolic acid, then we are going to oxidize it. We are also going to get what? Sacharic acid. We are going to get what? Sacharic acid. Clear everyone? ಇದು ಬಹಳ ಇಂಪಾರ್ಟೆಂಟ್ ಇದೆ. ಎಲ್ಲ ಕಾನ್ಸೆಪ್ಟ್ ಇಂದ ಬಹಳ ಇಂಪಾರ್ಟೆಂಟ್ ಇದೆ. You need to remember this very well. You need to remember this very well. Understood everyone? Clear? Done? Okay, let's move to the next part. That is, Fisher gave the exact spatial arrangement in a different, that is in the OH groups. Okay, this Fisher, this is also very important, guys, in both the perspective. I'll write it here, important. Okay. Fisher is a scientist, and he gave the exact spatial arrangement of the different OH group. Structure 1 represent the spatial arrangement, and the structure 2 and 3 will represent the glycolic acid. First, it will represent about the spatial arrangement of the glucose, and this both the things are about the glycolic acid. You have to do glycolic acid. Clear? So first one, understand how you need to do it. Now, how many carbon should be there? We should have a carbon should be 6. Clear? Let us write the carbon has a 6. Niಮಗೆ easy trick. ನಾ ಹೆಂಗ್ ಬರೀತೀನಿ ಅನ್ನೋದು. Okay? Carbon first to 6 ಬರ್ಕೊಂಡ್ಬಿಡೋದು. 1, 2, 3, 4, 5, 6. Then shall I name it also? 1, 2, 3, 4, 5, 6. 6 carbon ಆದ್ವಾ? Next. ಇನ್ ಕೇಸ್ ಯಾರು ಗೊತ್ತಿಲ್ಲ ಅಂದ್ರೆ ಹೇಳೋದು. ಓಕೆ, ಸೊ ಆಮೇಲೆ ಏನ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ಫಸ್ಟ್ ನೀವು RHS ಇಂದ ಹೋಗ್ಕೊಂತ ಹೋಗೋಣ. ಓಕೆ, ಫಸ್ಟ್ ಫ್ರಮ್ RHS ವಿಲ್ ಗೋ. ಫಸ್ಟ್ ವಿ ವಿಲ್ ರೈಟ್ ದ OH. ಓಕೆ, ಇದಂತೂ CHO ಅಂತ ಬರ್ಕೊಂಡ್ ಬಿಡ್ಬೇಕು. ಫಸ್ಟ್ ಮೇಲ್ಗಡೆ ಫಸ್ಟ್ ಕಾರ್ಬನ್ ಇರುತ್ತಲ್ಲ CHO, ಸೆಕೆಂಡ್ ಕಾರ್ಬನ್ ಬೇ CH2OH ಅಂತ ಬರ್ಕೊಂಡ್ಬಿಡಿ. ಕ್ಲಿಯರಾ? ಸೊ ಫಸ್ಟ್ ಕಾರ್ಬನ್ಗೆ CHO ಮತ್ತೆ ಸಿಕ್ಸ್ತ್ ಕಾರ್ಬನ್ಗೆ CH2OH ಅಂತ ಬರ್ಕೊಂಡ್ಬಿಡೋದು. ಡನ್. CH2OH. Now in between how to write it? Okay, in between how to write it? First ಬರ್ಕೊಳ್ಳೋದು ಸೆಕೆಂಡ್ ಕಾರ್ಬನ್ ಇಂದ OH, H, OH and OH. Clear? First you people will eat a sushi. ಓಕೆ, ಸೂಶಿ ತಿಂತೀರಾ, ಫಸ್ಟ್ ಟೈಮ್ ಸೂಶಿ ತಿಂತೀರಲ್ಲ ಅವಾಗ. ಸೊ ನನ್ನ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಪ್ರಕಾರ ಹೇಳ್ತಿದ್ದೇನೆ ನಿಮಗೆ, ಯಾರಿಗೆ ಸೂಶಿ ಸೇರುತ್ತೆ ಫಾಸ್ಟ್ ಚಾಟ್ ಬಾಕ್ಸ್ ನಲ್ಲಿ ಹೇಳಿ, ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡೋಕ್ಕಿಂತ ಮೊದಲೇ. ಓಕೆ, ಫಸ್ಟ್ ಸೂಶಿ ತಿಂತೀರಾ, ಅದಕ್ಕೆ OH ಅಂತ ಬರೀತೀರಾ. ಆಮೇಲೆ ನಿಮಗೆ ಸೇರಲ್ಲ ಸೂಶಿ, ಅದಕ್ಕೆ H ಅಂತ ಬರೀತೀರಾ. ವಿ ವಿಲ್ ನಾಟ್ ಈಟ್ ಸೂಶಿ ಓನ್ಲಿ. ಓಕೆ, ಆಫ್ಟರ್ವರ್ಡ್ಸ್ ಆಫ್ಟರ್ ಸಮ್ ಟೈಮ್ ಅಗೇನ್ ಯು ವಿಲ್ ಲೈಕ್ ಇಟ್. ವೈ? ಬಿಕಾಸ್ ಟೇಸ್ಟ್ ಬೇರೆ ಆಗುತ್ತೆ ಒಂದು ಸ್ವಲ್ಪ ತಿಂದಾದ ತಕ್ಷಣ. ಸೊ ಅಗೇನ್ OH and again OH. ಈಗ RHS ನಲ್ಲಿ ಎಲ್ಲ ಬರದ ತಕ್ಷಣ ಅಕಸ್ಮಾತ್ RHS ನಲ್ಲಿ OH ಇದ್ರೆ LHS ನಲ್ಲಿ H ಇರುತ್ತೆ, ಇಲ್ಲಿ H ಇದ್ರೆ ಇಲ್ಲಿ OH ಇರುತ್ತೆ, ಇಲ್ಲಿ OH ಇದ್ರೆ ಇಲ್ಲಿ H ಇರುತ್ತೆ, ಇಲ್ಲಿ OH ಇದ್ರೆ ಇಲ್ಲಿ H ಇರುತ್ತೆ. To balance it, simple, right? This is how you people need to write the glucose. Okay, so ಈಗ glycolic acid ಹೇಗುತ್ತೆ, ಎಲ್ಲ ಸೇಮ್, everything will be same. You can just check it out how it is there. Everything is same, just you need to, ಇಲ್ಲಿ CHO ಇದೆ, ಇಲ್ಲಿ COOH ಆಗುತ್ತೆ. It will become COOH. That's it. Done. Next comes what? Glycolic acid only, same only. In a structure 3 is also been given here. Everything is same itself. Just the thing is at the down also it will be changed. Okay. Sacharic acid. Sacharic acid. Okay. Sacharic acid. Clear everyone how to write it? Glucose ಬಂದ್ಬಿಟ್ರೆ ಗ್ಲೈಕಾನಿಕ್ ಆಸಿಡ್ ಸ್ಯಾಚುರಿಕ್ ಆಸಿಡ್ ಹೇಗೆ ಬರಿಬೇಕು, ಡ್ರಾ ಮಾಡಬೇಕು ಅನ್ನೋದು ಈಸಿಯಾಗಿ ಗೊತ್ತಾಗುತ್ತೆ. ಅಂಡರ್ಸ್ಟುಡ್? Next, reduction. How the reduction is happening? On prolonged heating with HI, there is a formation of N-hexane. There is a formation of what? N-hexane. That is a straight chain. That is going to be the straight chain. Now glucose, when we are going to glucose heated up with the hydrogen iodine, that is HI, we are going to get the product as CH3, CH2O, CH24 and CH3. That is going to be what? N-hexane. That will be what? N-hexane. Okay, clear? Understanding? CH3 ತಳಗಿರುತ್ತೆ. Yeah, that's true. CH3 ತಳಗಿರುತ್ತೆ ಮತ್ತೆ in between CH2 4 ಇರುತ್ತೆ. Clear? Now, in the presence of Na and Hg, okay, in the presence of Na and Hg and H2O, we are going to get CH2OH, CHOH4, CH2OH. That is called as what? Sorbitol. It is also called as what? Sorbitol. Clear? CH2OH, CH2OH, and in between CHOH4 will be present. Clear? Yes. Now comes the cyanohydrine formation. How the cyanohydrine formations are going to happen. Now here it gives the cyanohydrine when added a molecule of a hydrogen cyanide. When you add a molecule of a hydrogen cyanide, that time we are going to get a cyanohydrine. That time we will get a cyanohydrine. Clear? Understanding? So it gives a cyanohydrine when added a molecule of hydrogen cyanide. So glucose togondvi, when we are adding a HCN to it, we are going to get a product as what? Glucose cyanohydrine. Means what? CN will be getting added. So everything will be same here. Just the CN will be got added. Okay. CN will get added and it will produce. Matte hydrogen idella. Hydrogen add up aagbekkalla. So hydrogen also will get added up. Clear? Done. Next, oxamine formation. How oxamine formation is happening? To form an oxamine, glucose is being reacting with the hydroisamine. So it is getting reacted with what? Hydroxyamine. It is getting reacted with hydroxyamine. Oxamine antu gottide. Just add madi hydro annodu. So when you are going to do it, that NH2 and OH2, in the presence of it, we are going to get CH double bond NOH. That is called as glucose oxamine. So same everything, just you need to add up the, means bonding will be between CH and N and it will be with the OH also. Clear? So this is how you need to understand about the oxamine formation. Clear? Next comes reaction with the phenylhydrazine. That is the formation of a oxazone. Now, whenever you are taking a glucose, going to take a glucose, in the presence of a compound 3PHNH2, we are going to get a glycosone. This is how it's going to be forming. Clear? So these are all the formations. These all are formations of a, means reduction processes. In reduction process only you are learning this all things. Oxamine formation, reaction with phenyl, formation of ozonol. Now comes the next, that is going to be the acetylization. Okay, acetylization is important. They will ask this question also. Clear? Now, glucose pentaacetate is being formed by acetylization of glucose with acetic anhydride. This also confirms the presence of 5 OH groups. It also presents it acetylization and then 5 OH group anta. 5 OH groups means acetylization. Glucose which is present, that is glucose pentaacetate. Glucose pentaacetate is being formed. Glucose pentaacetate is there, no? This is being formed by acetylization of a glucose. With acetic anhydride. Clear? With with acetic anhydride, we are going to get the product as glucose pentaacetate. Glucose pentaacetate. Just you need to add up here what? CHOH4 ಇದೆ ಇಲ್ಲಿ CHOCOCH3 ಅಂತ ಹಾಕಬೇಕು ಅಷ್ಟೇ. Remaining things will be same, both the things will be same, just here 4 will be there, here 3 will be there, here CHO. Clear? So ಯಾವ ತರ ನೆನಪಿಟ್ಕೋಬೇಕು, ಟ್ರಿಕ್ಸ್ ಹೇಗೆ ಯೂಸ್ ಮಾಡ್ಕೋಬೇಕು ಅನ್ನೋದು ಅಪ್ಲೈ ಮೀನ್ಸ್ ದಿಸ್ ವಿಲ್ ಗೆಟ್ ಅಪ್ಲೈಡ್ ದೇರ್. ಓಕೆ, ಇವೆರಡು ಇಲ್ಲಿ ಎರಡಕ್ಕೂ ರಿಯಾಕ್ಷನ್ ಆಗುತ್ತೆ. this will get reacted with this both the things. Okay, it reacted with this both the things. This is called as acetalization. Acetalization andre ಏನು ನೆನಪಿಟ್ಕೋಬೇಕು, how the glucose pentaacetate is being formed by acetalization process where the glucose is going to be treated up with the acetic anhydride. Acetic anhydride ಜೊತೆ ಟ್ರೀಟ್ ಮಾಡಂತಲೇ ಏನಪ್ಪ ಫಾರ್ಮ್ ಮಾಡುತ್ತೆ, we will get it as a product CHOCOCOCH3 4 ಮತ್ತೆ ತಳಗಡೆ CH2COCOCH3. Clear? This is how the product we are going to get. Next comes the stereochemistry of the carbohydrates, that is D and L sugars. Okay, next comes what? Stereochemistry of a carbohydrates. This is also important in the perspective of KCET. KCET ನಲ್ಲಿ ಈ ತರ ಕ್ವೆಶ್ಚನ್ಸ್ ಕೇಳ್ತಾರೆ. stereochemistry of carbohydrates ಮೇಲೆ ಒಂದು ಕ್ವೆಶ್ಚನ್ ಜಾಸ್ತಿ ಬಿದ್ದಿದೆ ಆಯ್ತಾ. So D and L sugars where aldotriose, that is smallest carbohydrate, aldotriose which is also called as a smallest carbohydrates, example CHOCHOH and CH2OH, which is also glycosyl aldehyde. This is also called as what? Glyceryl aldehyde, where aldotriose, that is smallest carbohydrate which is present. Okay. Next comes what? Fischer projection. How the Fischer projection has been done of aldo means what is ಗ್ಲೈಕೋಸಿರಲ್ ಅಲ್ಡಿಹೈಡ್ಸ್ ಇದು ಫಿಶರ್ ಪ್ರೊಸೆಸ್ ಹೇಗಿದೆ ಮೀನ್ಸ್ ಮಿರರ್ ಇಮೇಜ್ ಹೇಗಿದೆ ಅನ್ನೋದು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಳ್ಳೋಣ. ಓಕೆ, ದಿಸ್ ಇಸ್ ಆಲ್ಸೋ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಓಕೆ, ದಿಸ್ ಇಸ್ ಆಲ್ಸೋ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. Now D which is there, wherever the D is there, that is going to be the H. ಅದನ್ನ ನೆನಪಿಟ್ಕೊಳ್ಳಿ. ಓಕೆ, ಯಾವಾಗ ಡಿ ಗ್ಲೈಕೋಸಿರೋ ಅಲಿಹೈಡ್ ಪಾಸಿಟಿವ್ ಸೈಡ್ ಇರುತ್ತೆ and H will be at the left side, and CHOOH and CH2OH. Now next comes what? L. If L is present, then you should remember as OH. OH andre L, D andre H. Okay, like this if you remember, then it will be easy. D means H, L means OH. Okay, then easily you can remember. Okay, yavaglu D positive irutte, L yavaglu negative agi irutte. This is how the Fischer projection is being done. Next comes the definition of that. That is the series of aldos or ketos in which the configuration of the penultimate C carbon atom, that is C next to the CH2OH group, is described as a D sugars. Means what? C next ಏನಿರುತ್ತಲ್ಲ CH2OH group ಇರುತ್ತಲ್ಲ ಅಲ್ಲಿ ಇದು ಡಿಸ್ಕ್ರೈಬ್ ಏನಾಗುತ್ತೆ, ಡಿ ಶುಗರ್ಸ್ ಅಂತ ಡಿಸ್ಕ್ರೈಬ್ ಮಾಡ್ತಾರೆ. ಇಟ್ ವಿಲ್ ಬಿ ಡಿಸ್ಕ್ರೈಬ್ ದ ಡಿ ಶುಗರ್ ಇಫ್ OH is towards the RHS. Each OH is towards the RHS. Here OH is towards the RHS. Clear? And L sugar if it is towards the LHS, it is going to be L sugar when it is going to be the towards the LHS. I told you trick also. This is also you can remember. It is also small trick only. Nanu one trick ಹೇಳಿದೆ, ಆ ತರನು ನೆನಪಿಟ್ಕೋಬಹುದು ಆಯ್ತಾ. Next comes what? Aldotetrose. So aldotetrose ನಲ್ಲಿ we have two types. What is that? Erythritose and triose. Okay, triose. How it will be pronounced? Yes. So aldotetrose ನಲ್ಲಿ ಎರಡು ತರ ಟೈಪ್ಸ್ ಇದೆ. ಏನು ಫಸ್ಟ್ ಒನ್ ಇದು ಇರಿಥ್ರೋಸ್ ಅಂಡ್ ಥ್ರಿಥೋಸ್. ಓಕೆ, ಐ ಡೋಂಟ್ ನೋ ಪ್ರಾಪರ್ಲಿ ಬಟ್ ಥ್ರಿಥೋಸ್ ಅಂತ ನೆನಪಿಟ್ಕೋಬಹುದು. ಐ ವಿಲ್ ಜಸ್ಟ್ ಪ್ರೊನೌನ್ಸಿಯೇಷನ್ ಸರಿ ಇದೇನೋ ಗೊತ್ತಿಲ್ಲ. ತಿಳಿದಾ? Yes. Let's start with the first one, that is going to be the D-trithrose and D-trithrose and L-trithrose and L-trithrose. Okay, means what? Everything will be same here. Everything will be same. If in case D is coming, then it is going to be what? I told you H. H will be present. D is there, then H. D is there, then H will be present. Clear? D is there, H is present. L is there, OH is present. L is there, OH is present. Simple to remember. So this way you can remember the things. Clear? Next comes how you should remember about the trithrose. That is going to be how much? How? So D is there, H will be present, L is there, OH is present. Clear? So in this way you can remember the pentose also. Pentose and ಎಷ್ಟು carbon ಇರಬೇಕು ಅನ್ನೋದು already ಒಂದು box ನಲ್ಲಿ short form ಆಗಿ ಹೇಳ್ಕೊಟ್ಟಿದ್ದೇನೆ. So refer that box and easily you can do it. Okay. Next, number of carbon is going to be 3 in the aldopentose and number of optical isomers is going to be what? 2 in raised to 3, that will be 8, and number of D sugars will be 4 and number of L sugars will be 4. Clear? Number of L and D sugars will be 4, 4. This is clear, everyone? Understood? Next, D-aldopentose. Now, in D-aldopentose, the all isomeric D sugars are going to be the diastromers. So, yella D sugars means all the exothermic D sugars are going to be the diastromers. It is going to be what? Diastromers. Clear? Now concentrate properly how the structures are there of the D-aldopentose. Okay, so this is how the structures will be. Everything is same at the same things. Just the thing is how the H and OH will be there, that is little bit different. Arrangement of those things is little bit different. Clear? So this is how you should remember it. This is also very important, guys. Okay. Next comes the aldohexose. Aldohexose nalli D-aldohexose ಇದೆ. Same ಅದೇ ತರ. Just you should remember that D is present, then L is present, then OH. Clear? So number of the carbon atoms are 4 carbon atoms are present here. 4 carbon atoms are present, and number of the stereoisomerism 2 raised to 4, that will be 16, and number of D sugars was 8 and number of L sugars is 8. Clear? Next comes cyclic structure of a glucose. Cyclic structure of a glucose. Now, the structure of the glucose has been explained, most of its properties, but the following reactions and the facts would not be explained by this structure. Okay. So, structure of the glucose explained most of the properties of those things, but in following reactions and facts, it was not able to explain those structures. ಏನಪ್ಪದು? The pentoacetate of a glucose does not react with hydrozomine amine. Okay, hydroxyne amine nalli react agalla. So pentaacetate ಏನಿದೆ ಅಲ್ಲ of glucose pentaacetate does not, it will not react only. Okay, it will so it will not react only with the hydroxyamine. Okay, it won't react with the hydroxyamine itself. Now, it is indicated by the absence of free CHO group indicators. Means we know that CHO group should be present, right? Glucose idre CHO group irbeku, but idralli pentaacetate of glucose nalli illa. Pentaacetate means what? Some of the things is not the structure. Now, in structure accept ಮಾಡ್ಕೊಂಡಿದ್ದೇವಲ್ಲ ಆ ತರ structure ಇಲ್ಲ. Glucose ರ structure ಇರಬೇಕು, but it is not in the form of a glucose. Clear? ಇಷ್ಟು ನೆನಪಿಟ್ಕೊಂಡ್ರೆ ಸಾಕು. Now, A and B are the names of the two different crystalline forms of a glucose. Like example, glucose ನಲ್ಲಿ alpha D plus ಮತ್ತೆ beta D plus glucose ಇದೆ. ನಾನು ಸ್ಟಾರ್ಟಿಂಗ್ ನಾನು ಹೇಳಿದೆ ಹೇಗೆ ಗ್ಲೂಕೋಸ್ ಇರುತ್ತೆ C6H12O6. ಯಾವಾಗಲೂ CHO ಗ್ರೂಪ್ ಇರಬೇಕು, ಸ್ಟಾರ್ಟಿಂಗ್ ನಲ್ಲಿ ಅಟ್ಯಾಚ್ ಇರಬೇಕು. ಸೊ ಈಗ ಪೆಂಟಾಸಿಟೇಟ್ ನಲ್ಲಿ CHO ಗ್ರೂಪ್ ಚೆನ್ನಾಗಿ ಆಕ್ಚುಲಿ ಅಟ್ಯಾಚ್ ಇಲ್ಲ. ಸೊ ಯಾಕಿಲ್ಲ ಅದು? ಬಿಕಾಸ್ ಇಟ್ಸ್ ನಾಟ್ ಆಕ್ಟಿಂಗ್ ಲೈಕ್ ಅ ಗ್ಲೂಕೋಸ್. ಓಕೆ, ಸ್ವಲ್ಪ ಕಂಪೌಂಡ್ಸ್ ಇದಾವೆ, ಅವು ಅದರಲ್ಲಿ CHO ಗ್ರೂಪ್ ಇಲ್ಲ. So it doesn't mean that it is not a glucose only. Okay, it is a glucose, but it doesn't have a group of CHO. This much. Okay, now let us see the types. Alpha D plus glucose and beta D plus glucose. Alpha D plus glucose andre enu? The A form of glucose where the melting point is going to be 416 Kelvin and is being obtained by crystallization. It is obtained by crystallization from concentrated solution of glucose. It's getting crystallization from the concentrated solution of glucose. Concentrated solution of glucose at 303 Kelvin. Now, ma'am, concentrated glucose nu irutta another question, right? It's correct. Ellargu ada confusion illa? Ma'am, concentrated glucose nu irutta? Yes, guys. Concentrated glucose nu irutte. We have concentrated glucose also. Clear? So next comes what? Beta D plus glucose. Now the B form, that is melting point, is going to be again the 423 Kelvin. Solpa jasti. is obtained by crystallization from hot and saturated aqueous solution, aqueous solution at 371 Kelvin. At how much? 371 Kelvin. Clear? Alpha D plus glucose ಮತ್ತೆ beta D plus glucose. ಇದು important to need to learn. It's important, need to learn. KCET ಮೇಲೆ questions ಬಂದಿದೆ. Don't miss this chapter, okay? Next comes how the structures will be of those things, okay? Alpha D plus glucose ಮತ್ತೆ beta D plus glucose ಹೇಗಪ್ಪ structures ಅನ್ನ form ಮಾಡುತ್ತೆ? So now concentrate properly how I'm going to explain you, okay? So first ಈಗ ನಮಗೆ alpha D plus glucose ಹೇಗೆ ಬರುತ್ತೆ ಅನ್ನೋದು ಹೇಳ್ತೇನೆ. ಸೇಮ್ ನೀವು ಹೇಗೆ ಗ್ಲೂಕೋಸ್ ಅನ್ನ ಡ್ರಾ ಮಾಡ್ತಾರಲ್ಲ, ನಾ ಹೇಗೆ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಟ್ರಿಕ್ ಹೇಳಿದ್ದೆ ನಿಮಗೆ. I had told you trick to form. ಫಸ್ಟ್ ಏನ್ ತಗೋತಾರ, ವಿ ಹ್ಯಾವ್ ಟೇಕನ್ CHO. ಎಷ್ಟು ಕಾರ್ಬನ್ ಇರ್ಬೇಕಂದಿದ್ದೆ? 6. 1 2 3 4 5 6. Done. 1 2 3 4 5 6 ಕಾರ್ಬನ್ಸ್ ಇದಾನ. ಸೊ CH2OH ಇರ್ಬೇಕು ಇಲ್ಲಿ ಲಾಸ್ಟ್ಗೆ, ರೈಟ್? ಇಲ್ಲಿ CHO ಇರಬೇಕು. ಫಸ್ಟ್ ಸ್ಟಾರ್ಟ್ ಮಾಡೋದು ಸುಶಿ ತಿಂತಾರ, ಆಮೇಲೆ ಬ್ಯಾಡ್ ಆಗ್ತದೆ, ಮತ್ತೆ ತಿಂತಾರ. ಸೊ OH ಇದ್ರೆ H ಬರಿಬೇಕು, H ಇದ್ರೆ OH ಬರಿಬೇಕು, ಸಾರಿ H ಬರಿಬೇಕು, ಇಲ್ಲಿದ್ರೆ H ಬರಿಬೇಕು, ಇಲ್ಲಿದ್ರೆ H ಬರಿಬೇಕು, ರೈಟ್? ದಿಸ್ ಇಸ್ ಅವರ್ ಗ್ಲೂಕೋಸ್, ರೈಟ್? ಸೊ ಇಲ್ಲಿ ಏನ್ ಜಸ್ಟ್ ಮಾಡಿದಾರೆ ಅಂದ್ರೆ, ದ ಫಸ್ಟ್ ಕಾರ್ಬನ್ ವಿಚ್ ಇಸ್ ಪ್ರೆಸೆಂಟ್, ಇಟ್ಸ್ ಗಾಟ್ ಕನೆಕ್ಟೆಡ್ ಟು ದ ಫಿಫ್ತ್ ಕಾರ್ಬನ್. ಸೊ ಇಲ್ಲಿ ಏನ್ ಫಸ್ಟ್ ಕಾರ್ಬನ್ ಇದೆ ಅಲ್ಲ, ದ ಫಸ್ಟ್ ಕಾರ್ಬನ್ ವಿಚ್ ಇಸ್ ಪ್ರೆಸೆಂಟ್, that has got connected to the fifth carbon. It is got connected to the fifth carbon. Means what? This is 1 2 3 4 5 6. 6 ಕಾರ್ಬನ್ ಇದೆ. ಫಸ್ಟ್ ಕಾರ್ಬನ್ ಹೋಗಿ ಫಿಫ್ತ್ ಕಾರ್ಬನ್ಗೆ ಅಟ್ಯಾಚ್ ಆಗುತ್ತೆ. That's it guys, that's it. ಸೊ ಆ ಅಟ್ಯಾಚ್ಮೆಂಟ್ ಏನಾಗುತ್ತಲ್ಲ, ಅದರಿಂದ ಈ ಕಾಂಪೌಂಡ್ ಅನ್ನ ತೆಗಿಬೇಕಾಗುತ್ತೆ. ಕ್ಲಿಯರ್? It's got attached like this. So this is called as what? alpha D glucose. ಇದಕ್ಕೆ ಏನ್ ಕರೀತಾರೆ? alpha D glucose ಅಂತ ಕರೀತಾರೆ. ಕ್ಲಿಯರ್? ನೆಕ್ಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಏನಿದೆ ಅಲ್ಲ, ಈಗ ನಮಗೆ ಗೊತ್ತಾಯ್ತು ಹೇಗೆ ಆಕ್ಚುಲಿ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗ್ತಿದೆ ಅನ್ನೋದು, ರೈಟ್? ಸೊ ಈ OH ಏನಿದೆ ಅಲ್ಲ, ಇಟ್ಸ್ ಗೆಟಿಂಗ್ ಟ್ರಾನ್ಸ್ಫರ್ ಟು ದೇರ್, ಓಕೆ? ಇಲ್ಲಿ ಏನ್ OH ಇರುತ್ತಲ್ಲ, ಹಿಯರ್ ಏನ್ OH ಇದೆ ಅಲ್ಲ, ದಟ್ ವಿಲ್ ಗೋ ದೇರ್. ಸೊ ಇಟ್ ವಿಲ್ ಫಾರ್ಮ್ ವಾಟ್? ಡಬಲ್ ಬಾಂಡ್ O. ಇಟ್ ವಿಲ್ ಫಾರ್ಮ್ ವಾಟ್? ಡಬಲ್ ಬಾಂಡ್ O. That is how the beta D plus glucose has been formed. Concentrate properly. Everything is same. Just the thing is that it will go upper end. Okay. CHO ಏನಿದೆ ಅಲ್ಲ, ಈ ತರ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. Clear? Understood? Yes, that's good. So this is very important. ಎರಡು ಪ್ರಾಸ್ಪೆಕ್ಟಿವ್ ಇಂದ, ಥಿಯರೀಸ್ ನಲ್ಲಿನೂ ಬಹಳ ಇಂಪಾರ್ಟೆಂಟ್ ಇದೆ. ಸೊ ಆರಾಮಾಗಿ ಸ್ಕೋರ್ ಮಾಡಬಹುದು ಬಯೋಮಾಲಿಕ್ಯೂಲ್ಸ್ ಇಂದ, ಇಫ್ ಯು ಪೀಪಲ್ ವಿಲ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದ ಕಾನ್ಸೆಪ್ಟ್ ವೆರಿ ವೆಲ್. ಓಕೆ, ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಳ್ಳಿ, ಸರಿಯಾಗಿ ತಿಳಿಯುತ್ತೆ. ಓಕೆ, ಯು ವಿಲ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಇಟ್ ವೆರಿ ವೆಲ್. Yes, next comes the Howard structure. So Howard structure means what? Now pyranose structure is a 6-membered cyclic structure of a glucose, and alpha or beta in a analogically with the pyran. Okay, analogically with the pyran. Now pyran is a cyclic organic compound with 5 carbon atoms and 1 oxygen atom in the ring. Okay, so pyran is actually what? Pyran is a cyclic organic compound with 5 carbon atoms. ಎಷ್ಟು carbon atoms ಇದೆ? Almost 5 carbon atoms ಇದೆ. Okay. Okay, and 1 oxygen atom in the ring. So ಎಷ್ಟು oxygens ಇದೆ? 1 oxygen is present, 1 oxygen atom is present in the ring. So you should remember what? Pyran is a cyclic organic compound, plus it has almost 5 carbon atoms and it has 1 oxygen atom. 1 oxygen atom and 5 carbon atoms are present in a ring cyclic structure, Then now the Howard structures given below are the cyclic structures of the glucose. This is a pyran. Pyran is present in this way. Now how you are going to write a alpha D plus glucose in the form of a cyclic structure? Okay, how you will write it in the form of a cyclic structure? Now you wrote straight chain structure, right? Straight agi baradri, addu baradri, ella mugitu. Iga pyran structure nalli hege baribekappa? How to write it in the form of a pyran structure? Let us see first with the alpha D plus glucose and beta D plus glucose. Alpha D plus glucose andre enu, matte beta D glucose andre enu. Now I told you people what, wherever the D is present at left LHS means LHS ನಲ್ಲಿ H ಇರಬೇಕು, right? So ನಾವು ಈಗ ಏನ್ ನೋಡ್ಕೊಳ್ಳೋದಂದ್ರೆ ಎಲ್ಲೆಲ್ಲಿ D ಇದೆ ಅಲ್ಲ, wherever the D is there, where I'm telling in the ಪೈರಾನ್ ನಲ್ಲಿ ಮಾತಾಡ್ತಿದ್ದೇನೆ, ಡೋಂಟ್ ಗೆಟ್ ಕನ್ಫ್ಯೂಸ್ಡ್. ನೋಟ್ ತರ ಬಡ್ಕೊಂಬೇಡಿ, ಕನ್ಫ್ಯೂಸ್ ಮಾಡ್ಕೊಳಕ್ ಹೋಗ್ಬೇಡಿ. ಇಲ್ಲಿ ಕನ್ಫ್ಯೂಸ್ ಬಹಳ ಮಂದಿ ಮಾಡ್ಕೋತಾರೆ. ಸೊ ಈ ಡಿ ಇದೆ ಅಲ್ಲ, LHS ನಲ್ಲಿ H ಇದ್ರೆ ಮ್ಯಾಮ್ ಇಟ್ಸ್ ಆಲ್ಫಾ ಡಿ ಗ್ಲೂಕೋಸ್ ಅಂತ. ಇನ್ ಕೇಸ್ ಡಿ ಪಾಸಿಟಿವ್ ನಲ್ಲಿ ಇದ್ರೆ OH ಇದ್ರೆ ಇದನ್ನ ನಂತರ ಹೇಳಿದ್ದೆ. ಬಟ್ ಇಲ್ಲಿ ಏನಾಗುತ್ತಂದ್ರೆ ಇಫ್ ಇನ್ ಕೇಸ್ ಇಟ್ ಇಸ್ ಅ ಡಿ, ದೆನ್ ದ H will be at the upper end. If it is a beta, one second guys, if it is going to be the alpha, then the RHS ನಲ್ಲಿ H ಮೊದಲು ಇರುತ್ತೆ. If in case beta, then RHS ನಲ್ಲಿ OH ಮೊದಲು ಇರುತ್ತೆ. ನಾನು ಈಸಿ ಟ್ರಿಕ್ ಇದು ನೆನಪಿಟ್ಕೊಳ್ಳಿಕ್ಕೆ, ಈಸಿ ಟ್ರಿಕ್ ಸ್ಟ್ರಕ್ಚರ್ಸ್. ಓಕೆ, now ನೋಡಿ, first we know already that is the pyran. We have our 6 structures, we have 6 carbons here. Concentrate 1 2 3 4 5 6, done. We have a 6 carbons, done. Yes. Next step is what? Now you have named all the structures from here. Okay, now you have drawn everything. O everywhere OO is present. Now from where you are going to start? Everywhere you first draw the lines like this. Ee tara lines ana takkondu bidodu, tilita? So now you have name, you should start naming the reactions like 1 2 3 4 5. Okay, done. Next step, what you need to do, first we'll start with the O itself. Okay, first we'll start with the 1 itself. I told you alpha is there, then alpha is present, then H will be first. And beta is present, then OH will be first. Okay, OH will be first. ಈಗ ಫಸ್ಟ್ H ಬರೆದ್ವಿ, H ಇದ್ರೆ ಇಲ್ಲಿ OH ಬರುತ್ತೆ, H ಇದ್ರೆ OH ಬರುತ್ತೆ, OH ಇದ್ರೆ H ಬರುತ್ತೆ. ಕ್ಲಿಯರ್? OH ಇದ್ರೆ H ಬರುತ್ತೆ, H ಇದ್ರೆ OH ಬರುತ್ತೆ. ಕ್ಲಿಯರ್? ಸೊ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ HOH 3 ಇದೆ, ಮತ್ತೆ OH 1 ಇದೆ. ಕ್ಲಿಯರಾ? 3 1. ನಾನು ಹೀಗೆ ನೆನಪಿಟ್ಕೋತಿದ್ದೆ, just I'm telling a trick. If you want to use it, you can use it, or else don't want. It's your wish. Okay, now in this way you can write it. Now at the end what comes? At the end what comes? Always it will be CH2OH, CH2OH and H. Done. Same way here also it is. Everything is same, just the thing is beta it is there, so it will be always be OH. Okay, OH din start ಮಾಡಿ LH ಹಾಕಿದಾರಲ್ಲ ಅಲ್ಲಿ OH ಹಾಕ್ಬಿಡಿ. Simple. This is how you can write the pyran structure. How you can write with the help of the pyran structure. Then, so this is a pyran. Okay, this is a pyran. Next, fructose. What is the meaning of an fructose? Now you learned all about the glucose. Now let's go to the fructose. What is fructose? Fructose is an important ketohexose. It is an important ketohexose. It is also has a molecular formula C6H12O6. So it's having a molecular formula of C6H12O6. Ma'am, it is also a glucose only. Glucose structure ade alla ma'am. But same ಎರಡು same ಕೊಡ್ತಿದಾರಲ್ಲ. Why? Right? So now you will understand why it is actually. Okay, why it is actually you'll understand. Now example, it is obtained by the hydrolysis of disaccharides. Okay, it is actually hydrolyzed. It is going to be produced by hydrolyzing the disaccharide. Okay, how hydrolyzing the disaccharide? You have learnt it already, just I'm repeating it again. Sucrose, by hydrolyzing we are going to get a glucose, that is C6H12O6, and we are going to get a fructose in an equal amount, H12O6 and C6H12O6. So we are going to get both the things in an equal amount nalli sigutte. Done. So it is a natural monosaccharide found in a vegetables, fruits and honey. So it is a very natural monosaccharide. Ide, right? So it is found in a vegetables, fruits and honey. Clear? Next comes, it is a Levosteri compound and belongs to D series. It is actually belong to D series. It is approximately written as, it is how can be written as, in this form you can write it as fructose. Glucose tarane same, ella glucose tarane, just the thing is one extra will be there, 3 6 will be there, same everything. First starting nalli sushi and tintaralla, and sushi tagiri mate oxygen tinbedi ashte, double bond O. Clear? So this much you can remember for the D fructose. Clear? Understood? Next, cyclic structure of a fructose. Now, how you are going to write a cyclic structure? So, we have everywhere the cyclic structure, normal structure, and then we have a pyrene structure also. Pyrene structure andre here the cyclic form ring nalli aa tara. Okay. Let's start with the cyclic structure. This structure is being obtained by addition of OH at C5 to the ketonic group. C5 to the ketonic group, which produces two cyclic forms, which will produce what? Two cyclic forms will be produced. So concentrate properly. Alpha D fructofuranase, same ಅದೇ ತರ ಏನ್ oxygen, sorry, carbon first ಇರುತ್ತಲ್ಲ LHS side ನಲ್ಲಿ ಇರುತ್ತೆ. Carbon will be at the LHS side. Same it will be getting connected. So it is getting connected from the carbon 2. ಎಲ್ಲ ಕಡೆ carbon 1 ಇಂದ connect ಆಗ್ತಿತ್ತು, but ಇಲ್ಲಿ fructose ನಲ್ಲಿ carbon 2 ಇಂದ connect ಆಗುತ್ತೆ. ಕ್ಲಿಯರಾ? So carbon 2 ಇಂದ connect ಮಾಡಿ, it will be coming in this way O, and it's connected to the OH. Means ಇಲ್ಲಿ OH ಇರುತ್ತೆ, ಇಲ್ಲಿ COOH ಆಗುತ್ತೆ. ಕ್ಲಿಯರ್? ಇದು actually COOH. Okay, ಇದನ್ನೇ ಹಿಂಗ್ ಬರ್ದಿದ್ದಾರೆ. Done? Yes, this is how the thing is going to form. This only OH will be going there. So CH2OH and OH will be produced. So that will be what? Beta D fructose will be produced. Clear everyone? Understanding? Yes. Next comes what? Howard structure of this. How the Howard structure of the fructose is. ಈ glucose ನೋಡಿದ್ವಲ್ಲ ಅದೇ ತರ fructose ದು. Now ring has an analogy of the compound furan and is 5-membered ring. It is a 5-membered cyclic compound with oxygen and 4 carbon atoms. Now furan which is present is in the form of alpha D fructofuranose. It's in the form of alpha D fructofuranose and beta D fructofuranose. How you should remember? I'll actually ಏನಾಗಿತ್ತು ಎಷ್ಟು ರಿಂಗ್ ಸ್ಟ್ರಕ್ಚರ್ ಇತ್ತು? actually 6 ಇತ್ತು. ಗ್ಲೂಕೋಸ್ ನಲ್ಲಿ 6 ಇತ್ತು. ಇಲ್ಲಿ ಏನಿಷ್ಟಿರುತ್ತೆ? 5-membered ring it is. Okay, it's actually a 5-membered ring, not a 6-membered ring. It's a 5-membered ring. So how you are going to produce the things now concept? So ಎಲ್ಲ same. First we are going to start with CH2OH. Okay, CH2OH, OH ಅಲ್ಲಿ ಎಂಡ್ ಆಗಿ ಬರ್ತಿತ್ತು. ಇಲ್ಲಿ ಎಂಡ್ ಇದೆ ಅಪ್ಪ, ಇಲ್ಲಿ ಎಂಡ್ ಇದೆ. CH2OH. Done. So next afterwards, wherever you are going to add a CH2OH, there down will be the H. So here what happens in the D, if alpha is present, then H and OH will be pressed. Okay. Andre ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಸೇಮ್ ಅದೇ ತರ ಎವ್ರಿಥಿಂಗ್ ವಿಲ್ ಬಿ ಸೇಮ್, ಜಸ್ಟ್ ದ ಥಿಂಗ್ ಇಸ್ ಉಲ್ಟಾ ಪುಲ್ಟಾ ಆಗುತ್ತೆ. ಓಕೆ, ಹಿಯರ್ ದ ಥಿಂಗ್ಸ್ ವಿಲ್ ಬಿ ಉಲ್ಟಾ ಪುಲ್ಟಾ. ಕ್ಲಿಯರ್? ದಟ್ ಇಸ್ ಕಾಲ್ಡ್ as beta D fructofuranose. Okay, fructofuranose. This is the Howard structure of those. Okay, it is the Howard structure. Clear? Yes, this is the comparison of a glucose and the fructose. Properties ಕೊಟ್ಟಿದ್ದಾರೆ, molecular formula of the glucose and the fructose means comparison of a glucose and comparison of a fructose. I don't know, it's visible properly, no problem. Okay, molecular formula C6H12O6 ಹೇಳುತ್ತಿರೋದು ಅದೇ ಇದೆ. ನೇಚರ್ ಏನಿದೆ? ಪಾಲಿಹೈಡ್ರಾಕ್ಸಿ ಅಲ್ಡಿಹೈಡ್ ಇದೆ, ಗ್ಲೂಕೋಸ್ ಪಾಲಿಹೈಡ್ರಾಕ್ಸಿ ಅಲ್ಡಿಹೈಡ್ ಇದೆ, ಫ್ರುಕ್ಟೋಸ್ ಪಾಲಿಹೈಡ್ರಾಕ್ಸಿ ಕೀಟೋನ್ ಇದೆ. So this is aldehyde. Glucose means aldehyde and fructose means it's going to be ketone. Okay, it's going to be the ketone. Next comes what? Melting point is actually 146 degrees Celsius in the glucose. In the ketose it will be how much? 102 degrees Celsius. Clear? So optical nature is detroxy rotatory and it will be what? Leo rotatory. It will be what? Leo rotatory. Clear? Yes, next comes Mollis test. Here it is going to be the violet color and here also it will be violet color itself. Then the Tollens reagent where it will be a silver mirror and here also silver mirror. Film solution nalli red PPT form agutte eradu kade. Clear? Pinyl hydrazine tade forms ozone, forms also ozone. Next oxidation by concentrated HNO3. Now one reaction ಮಾಡಿ ತೋರಿಸಿದೆಲ್ಲ ಅದರ ಬಗ್ಗೆ ಡಿಸ್ಕಸ್ ಅದು. ಓಕೆ, ಸ್ಯಾಚುರಿಕ್ ಆಸಿಡ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ, ಬಟ್ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ? ಮಿಕ್ಸ್ಚರ್ ಆಫ್ ಗ್ಲೈಕೋಲಿಕ್ ಆಸಿಡ್, ಟಾರ್ಟರಿಕ್ ಆಸಿಡ್ and trihydroxyglutaric acid. Glutaric acid will be formed in the fructose. Okay, fructose ನಲ್ಲಿ ಎರಡೇ ಚೇಂಜಸ್ ಇರೋದು. ಒಂದು ಇರೋದು ನೇಚರು, that is going to be ketone, that is going to be aldehyde. ಮತ್ತೆ ಇನ್ನೊಂದರೆ ಆಕ್ಸಿಡೇಷನ್ ಬೈ ಕಾನ್ಸಂಟ್ರೇಟೆಡ್ H2O ಜೊತೆ HNO3 ಜೊತೆ ಆವಾಗ ಮಿಕ್ಸ್ಚರ್ ಆಫ್ ಗ್ಲೈಕೋನಿಕ್ ಆಸಿಡ್, ಟಾರ್ಟರಿಕ್ ಆಸಿಡ್, ಟ್ರೈಹೈಡ್ರಾಕ್ಸಿ ಆಸಿಡ್ and ಟ್ರೈಹೈಡ್ರಾಕ್ಸಿ ಗ್ಲಿಕ್ಟೋರಿಕ್ ಆಸಿಡ್ ಅನ್ನ ಫಾರ್ಮ್ ಮಾಡುತ್ತೆ. ಕ್ಲಿಯರಾ? ಫಾರ್ಮ್ ಮಾಡುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಕಮ್ಸ್ ವಾಟ್? Oh yeah, this is done. No, wait one second, guys. No, I think in detail we are going to learn this. Okay, disaccharides. So what happens in the disaccharides? By the loss of the water molecule, an oxide linkage is being formed. What has been formed? Oxide linkage is being formed, which joins two monosaccharides. Which will join what? Two monosaccharides. So ಅದಕ್ಕೆ disaccharides ಅಂದ್ರೆ ಏನು? Two. Okay, two monosaccharides will be present in it. Now, these two monosaccharides are held together by a glycosidic linkage that is also called as oxide linkage. That is also called as what? Oxide linkage. And though through the oxygen atom. Oxide linkage through oxygen atom. Then next comes what? The reducing groups. So reducing groups means what? Aldehydic or ketonic. Reducing groups are aldehydic or ketonic of monosaccharides are bounded in disaccharides. Therefore, these are non-reducing sugars. Okay. Examples we can give it as sucrose. Then where has sugars in which these reducing groups are completely free, which are called as reducing sugars. For example, lactose and maltose. This is all we have discussed it already. Just we are repeating the words because in detail I kaltidavala adike. Okay. Now in this we are going to learn about the sucrose. We will learn about the sucrose. Clear? Okay. Let's have 5 minutes break. 5 minutes break. I'll be back in 5 minutes. Okay. Okay, then. Let's start. Audible, visible properly to everyone now. Yes, let's start the chapter now. Yes. Sucrose, let us start. Sucrose, let us start. Okay. On hydrolysis of sucrose, the equimolecular mixture of D plus glucose and D minus fructose are being formed. So whenever you are taking a sucrose, okay, yavag now sucrose tagotevalla, sucrose in the presence of hydrogen means H plus, we are going to get a D glucose and D fructose. Means what? D glucose and D fructose andre yav tara formation agutte structures anna. Okay, idu ನೀವು structure form ನಲ್ಲಿ ಬರಿಬಹುದು. It's not like no, you can't write it in a structure. You can write it in the structure form also. Clear? You can also write it in the structure form also. Okay. Next, bioglucosidic linkage between C1 of alpha D glucose and C2 of beta D fructose. These two monosaccharides can be held together. So monosaccharides, we have to monosaccharides, they can held together. Clear? And sucrose is a non-reducing sugar, has a reducing groups of the glucose and fructose is involved in the formation of a glycosonic bonds. Yedakillappa? Because it is formation. You have to involve agide glycosidic bond alli bond madlikke involve agide at the salವಾಗಿ it is a non reducing sugar. Clear? This is also important, like give reason, application based. Okay, it's application based question. Okay, clear? Next, so this is the structure alpha D glucose, how the glycosidic linkage has been happening and how the sucrose has been forming. Clear? How the sucrose has been forming. Important, most important. Okay, very much important, guys. Okay. So ಇಲ್ಲಿ ನೋಡಿ alpha D glucose ಇದೆ, alpha D glucose ಇದೆ, CH2OH ಇದೆ, H, same everything you are going to draw. Just the thing is there will be a linkage between both the things. Here what will be there? CH2OH ಇದೆ, ಈ ಕಡೆ D ಏನಿದೆ ಅಲ್ಲ D glucose, alpha D, beta D glucose ನಲ್ಲಿ ನಿಮಗೆ ಹೇಳಿದ್ದೆ LHS side, LHS side CH2OH ಇರುತ್ತೆ. ಓಕೆ, LHS side CH2OH ಇರುತ್ತಲ್ಲ ಅದು ಆಕ್ಸಿಜನ್ ಜೊತೆ ಮತ್ತೆ ಹೈಡ್ರೋಜನ್ ಜೊತೆ ಬಾಂಡ್ ಆಗುತ್ತೆ. You can just observe here how the linkage will be forming. Clear? So ಅದಕ್ಕೆ ಹೇಳೋದು ಯಾವ ತರ ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ, ಡಿ ಬಂದ್ರೆ ಏನಂತಪ್ಪ ಫಸ್ಟ್ ಎಚ್ ಇರುತ್ತೆ, ಇಫ್ ಇನ್ ಕೇಸ್ ಬೀಟಾ ಡಿ ಇದ್ರೆ ಫಸ್ಟ್ ಎಚ್ ಇರುತ್ತೆ ಬಟ್ ತಳಗಡೆ CH2OH ಇರುತ್ತೆ. ಡನ್. ಸೊ ಈ ತರ ಯು ನೀಡ್ ಟು ಯೂಸ್ ಯುವರ್ ಟ್ರಿಕ್ಸ್ ಅನ್ನ ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ, ಬಿಕಾಸ್ ಎಲ್ಲ ಸ್ಟ್ರಕ್ಚರ್ ಸೇಮೇ ಕಾಣುತ್ತೆ ಬಯೋಮಾಲಿಕ್ಯೂಲ್ಸ್ ನಲ್ಲಿ. ಸೊ ಅದ್ರ ಸಲುವಾಗಿ ಕನ್ಫ್ಯೂಷನ್ ಚಾನ್ಸಸ್ ಜಾಸ್ತಿ ಇದೆ. ಓಕೆ, ಕನ್ಫ್ಯೂಷನ್ ಜಾಸ್ತಿ ಆಗಬಹುದು. ಅದ್ರ ಸಲುವಾಗಿ ಅಲ್ಫಾ ಡಿ ಇದ್ದಾಗ ಯಾವ್ದು ಹೈಡ್ರೋಜನ್ ಮೇಲ್ಗಡೆ ಇರುತ್ತೆ ಮತ್ತೆ ತೆಳಗಡೆ ಇರುತ್ತೆ ಅನ್ನೋದು ನೆನಪಿಟ್ಕೊಳ್ಳಿ. ಇಟ್ ವಿಲ್ ಬಿ ಈಸಿ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್. ಓಕೆ, ಸೊ ಅಲ್ಫಾ ಡಿ ಗ್ಲೂಕೋಸ್ ಇದ್ರೆ ಏನಾಗುತ್ತಪ್ಪ, ಹೈಡ್ರೋಜನ್ ಮೇಲ್ಗಡೆ ಇರುತ್ತೆ, ಅಂಡ್ ಬೀಟಾ ಡಿ ಫ್ರುಕ್ಟೋಸ್ ಇದ್ರೆ ಏನಿರುತ್ತಪ್ಪ, CH2OH ಮೇಲ್ಗಡೆ ಇರುತ್ತೆ. That's it. Clear? This is how the linkage will be forming. This linkage is actually called as what? Glycosidic linkage. It's called as what? Glycosidic linkage. So this is the whole thing is called as a sucrose. This is the structure of a sucrose. Now we will be learning about full structure of different things also. Just make sure you will practice the sucrose structure. It's important in the prospective wise KCET also and for the PU board also. PU board ಗೂ ಇಂಪಾರ್ಟೆಂಟ್ ಇದೆ ಮತ್ತೆ KCET ಗೂ ಇಂಪಾರ್ಟೆಂಟ್ ಇದೆ. Next, it is a detoxyrotatory, but also about hydrolysis. It gives the levanterary fructose and deoxyribonucleic glucose. Since the dextrotation of a glucose, that is going to be how much? Plus 52.5 degrees Celsius. It is less than the livo-rotation of fructose, that is minus 92.4 degree. Hence, the mixture is going to be what? Livorotatory. Okay. Now, inward sugar in the product is the product formed when there is a change in the sign of the rotation. If there is a change in the sign of the rotation, there will be a change in the product formation. Okay, there will be a change in the product formation. So now from dextro, that is plus, to the levo, minus, after the process of the hydrolysis of the sucrose. When you hydrolyze the sucrose, that time these things will be formed. Clear? Next comes the maltose. Maltose means what? It is a maltose of C1 of a one glucose is linked to the C4 of the another glucose unit. Concentrate properly what I discussed about the sucrose and what I am discussing about the maltose. Don't get confused. We might get confused, but you should not get confused because this is very important concept. Bala sala kero questions you full like confused ಮಾಡ್ಕೊಳ್ಳೋಕೆ ಹೋಗಬೇಡಿ. Understood? Yes, in maltose, C1 of the one glucose is linked to the C4 of the another glucose. Another glucose unit. That will be 2 of the 2 alpha D glucose units. Now, in solution, C1 of the second glucose produces a free aldehydic group. So, yawaga C1 of the second glucose will be present, means carbon of the second glucose will be present. That is free aldehyde group will be formed. Free aldehyde group will be formed, and it is reducing sugar has it is a reducing properties. As we know that it is a reducing sugar, but sucrose is not. Sucrose is not a reducing sugar. Maltose is a reducing sugar. Clear? So maltose is a reducing sugar as it is a reducing properties. Then next, how the structure will be. Same, everything will be present. Just the thing is here CH2OH will not be present. Clear? ನೀವೇ ನೋಡ್ಕೋಬಹುದು. You can compare the things. Just little changes are present. In this way, you can just remember the concepts. Okay. Sucrose nalli CH2OH irutte. Matte maltose nalli it will be present CH2OH. That's it. Okay. H tagiri, H tagada takshana CH2OH na haki. So ashte ಆದ್ರೆ glucose ಮತ್ತೆ sucrose ಮತ್ತೆ maltose clear ಆಗುತ್ತೆ. Right? Understood? Understood till here? Yes. Next thing comes lactose. So lactose is found in the milk. So it is actually commonly known as a milk sugar. Commonly it's known as what? Milk sugar, and it is composed of beta D lactose and beta D glucose. It has a linkage between C1 of the galactose of C4 of the glucose, and it is also considered as reducing sugar, has free aldehyde group, may be produced at C1 glucose unit. So where the free aldehyde will be present? At the C1 glucose of a unit. Clear? Next comes, this is the structure of the lactose, how it's going to be there. So it will be same itself, just you need to think lactose means what? Zigzag process, or else you can tell it N process. Okay, N process it is. Here the O will be present. Clear? Next comes what? Polysaccharides. So polysaccharides is we have discussed already. I'll revise it once again. When a large number of monosaccharides units will link together, those all are called as a polysaccharides. Clear? Next comes the starch. So it is main storage polysaccharides of a plant's high content of a starch is being found in some of the vegetables, roots, tubers and cereals. Hence it is also a most important dietary sources for the human beings. So only starch will be used for the purpose of diet a lot. Okay. Next, it is polymer of alpha glucose and consists of two components of amylophatic and amylose. Clear? And amylose. Clear? Next, amylose means what? There is a structure, amylose structure, which you people need to remember how the alpha linkage and alpha link will be happening in between. This is the alpha link, and here the alpha link in between the two oxygen atoms, where how it has got attached. This will continue. Okay, alli continue agutte, illi continue agutte. Then next comes amylopectin. So this is the structure of the amylopectin, how it's been done. amylopectin. Understood? Same only it will be, just the linkage will be at the branch at carbon 6. Amylopectin is at the branch at 6. Clear? At the branch 6 it will be connected. Clear? Understood? Next comes the cellulose. So cellulose is present mostly in the plants and is the most abundant organic substances in the whole plant kingdom. In the whole plant kingdom, it is found mostly in the cell wall of the plant cell. It's present in the cell wall of the plant cell, and it is composed of only alpha D glucose units and is a straight chain polysaccharides, and mainly which are actually linked by what? Glycosonic linkage between CN of the one glucose unit and C4 of the next glucose unit. You need to remember these things, okay? Then only the structure will be easily be understandable, okay? Hey, understand the structures ee tara. How the linkages will be done in this way. How the first oxygen atom which will be connected to the second one, and then the third one. Done? Next comes the glycogen. Here what happens? It is an animal body glycogen and is stored in the form of a carbohydrates. It's stored in the form of a carbohydrates, and its structure is similar to the amylopectin. That's why it is also known as a animal starch and is rather more highly branched Clear? Now it is present in brain, muscles and liver, and enzymes break the glycogen down to the glucose whenever the body wants the glucose. Clear? This at least you know how it will work, right? So this is how the easy way to remember about the glucose. This is the carbohydrates, the type of them, and the reducing and the non-reducing, whether it is reducing or non-reducing. That is also very important in the KCET. Clear? So yav reduce aagtide, yav non-reduce aagtide, adu important ide. Make sure you people will practice this very well. Okay? Next comes its units and its linkages also. What is the importance of carbohydrates? In life, both plants and animals, they are essential as they form a large portion of our food. As you people know, carbohydrates is present everywhere. Nam dinna carbohydrates ana tinteve, right? So carbohydrate irilla andre we won't feel it full. Okay, hotti tumballa. Yaku tumballa? When the carbohydrates are not there, that time stomach will not fill. Done? Next, it is used for the long time as an instant source of energy. Yes, we use it as a form of instant energy also. Okay, and starch and glycogen forms this are used to storage the molecules in plants and animals respectively. Even the starch and the glycogen is used to store the food also. Then cell wall of the plants and bacteria is made from the cellulose. Clear? So they provide the various raw materials for many important industries like paper, textiles, lacquers and breweries. Okay. Next comes the proteins. So what is the proteins? So Benzelius introduced the term protein, which means first protein is actually equal to the first. That is, they are most of the abundant biomolecules of a living system. Chef sources the proteins are cheese, milk, pulses, peanuts, etc. And we use the protein in our daily life. Daily food nalli protein irbeku. Intake of protein should be good. Clear? Intake of the protein should be good. Next, they also required for maintenance and the growth of the body. Okay, they also are required for the maintenance and the growth of the body also, and it is derived from the Greek word proteins, which means primary of the prime importance. So this is cellulose is actually commonly used in the fruits and bakeries. You people know it already. Okay, amino acids. This is also very important concept, guys. Amino acid is also very important. Amino acids are carboxylic acids having an NH2 group. When the NH2 group is at the alpha position, these are called as alpha amino acids. And here alpha amino acids are going to be the general equation, this one. Okay, and amino acids can be catalyzed as alpha, beta, gamma, sigma and so on. It depends on the relative position of an amino group with respect to the carboxylic group. only alpha amino acids are obtained on the hydrolysis of proteins. On the hydrolysis of proteins, they also can connect other functional groups. And the property of the compound or its sources are reflected by their trivial names. It's actually reflected by their trivial names. And the glycine is also called has a sweet taste also, and trypsin is also called as a first obtained from the cheese. So this trypsin is actually obtained from the cheese. Clear? Amino acids are generally represented by a 3-letter symbol. Sometimes 1-letter symbol is also being used. Okay, 1-letter symbol also has been used. Next comes the classification of amino acids. So, ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ classification of amino acids ನಲ್ಲಿ neutral, basic ಮತ್ತೆ acidic 3 ತರ ಇರುತ್ತೆ. Neutral ಅಂದ್ರೆ ಏನಪ್ಪಾ? Equal number of carboxylic acid and amino groups makes it neutral. And basic ಅಂದ್ರೆ more number of amino than the carbonyl groups makes it basic. More ಅಂದ್ರೆ ಏನು? Number of amino will be more there, and then the carboxylic groups ಗಿಂತ ಜಾಸ್ತಿ amino ಇದ್ದಾಗ basic ಅಂತ ತಿಳ್ಕೊಂಬಿಡಿ. ಆಯ್ತಾ? Acidic ಯಾವಾಗಿರುತ್ತೆ? More carboxylic groups will be present and less amino groups will be present. Clear? So this is going to be classification of amino acids. So what are non-essential amino acids? Understanding? Yes, what are non-essential amino acids? So these are the defined as type of amino acid which can be synthesized in the body. It can be synthesized in the body are called as non-essential amino acids. Clear? Now essential amino acids means what? Essential amino acids are defined as the type of amino acid which cannot be synthesized in the body. Which cannot be synthesized in the body, and most of them are obtained by the diet. And their deficiency causes or diseases. It causes diseases. Examples of essential amino acids include vaseline, leucine, isoleucine, lysine, tyrosine, vinyl, alanine, methylene, tripoline, histidine, and arginine. Okay, these are some examples which we can give it for the essential amino acids. Non-essential amino acids will be synthesized itself. Okay, non-essential amino acids will be synthesized. Yes, understanding, very good. Essentials and essential amino acids will be like which cannot be synthesized itself. It cannot be synthesized itself. Done. So this is also a small thing like characteristic features of the side chain reactions and how it's been formed. Okay. Next comes what? Characteristic features of amino acids. So amino acids are generally colorless crystalline solids. So these are water soluble and have a high melting point. It has a very high melting point and they are water soluble. Amino acids are water soluble and they have a highest melting point. Clear? And these are behave like salts rather than the simple amines. Okay. Usually ಹೇಗೆ behave ಮಾಡುತ್ತೆ? Salt ತರ behave ಆಗುತ್ತೆ rather than being amines or carboxylic acids. Okay. Carboxylic acids irala, simple salts irala, just it will behave like a simple salts. Okay. They are just a simple salt. This behavior is due to the presence of both basic and acidic groups in the same molecule. So basic and acidic group bearu same molecule like amino group and a carboxylic group, both the things are present. No? For that purpose they will act like a simple salts. Okay, all amino acids they will act like a simple salts because they have both the groups. Clear? Next comes the zwitterion. So in aqueous solution, amino group can accept a proton and the carboxylic group can lose a proton. Okay, carboxylic group can lose a proton, which give rise to dipolar ion termed as zwitterion. Clear? So this is going to be the zwitterion. Okay, how the structure is gonna form. Clear? Next comes the peptide bond or peptide linkage. Next comes what? Peptide bond or peptide linkage. One second, guys. Yes. So peptide bond and peptide linkage ಏನಾಗುತ್ತೆ? So peptides are those amides which are formed due to the condensation between 2NH2 group and COOH group. Okay, it is a condensation between two NH2 group and one COOH group. Okay. So here what happens, two different amino acids are present here, and the CONH bond is actually called as peptide linkage. It's actually called as peptide linkage or a bond also. Okay. And here what happens, the carbon is always, this is how the structure is gonna, group will be formed. C double bond O. Okay. C double bond O means what? Peptide linkage. Okay. Of a amide is almost sp2 hybridization with a coplanar structure. So, ಯಾವ structure ಇದೆ ಇದು? Coplanar structure, and the hybridization will be what? sp2 hybridization will be present. Clear? This is how the structure is going to be forming. Clear? So, ಇಲ್ಲಿ ನೋಡಿ ಹೇಗೆ structure form ಮಾಡುತ್ತೆ, means what it is done, giving out the one electron to there. It's giving one electron to here, so it becomes double. Okay? Clear? Understood? Next, to eliminate the water molecules and forms the peptide bond, CONH, the combination of the amino group of a one molecule with the carboxylic group of a other, there is a reaction between two molecules of similar or a different amino acids. Then the product of the reaction is made up of two amino acids, hence it is called as, termed as dipeptide, because two amino groups will be present. How we learned, no, mono, di and disaccharides and all, same way here also two amino groups are present. For that purpose we will call it as dipeptide. Two are there, no, two are there, so for that means dipeptide. If it is three, then it will be tripeptide, like that. Okay, example annu kottidare. This is the structure of glycine, alanine, aniline. This is how the structure is going to form. This is also important, guys. Okay. Then the tripeptide contains three amino acids linked by two peptide linkages. Therefore, it can be formed the third amino acid. Okay. It will be formed with what? Third amino acid combines to the dipeptide. Combines to what? Dipeptide. Clear? So, when 4, 5 or 6 amino acids are linked, the respective products are termed as tetrapeptide, pentapeptide or hexapeptide. Depends, like 4 idre tetrapeptide, 5 idre pentapeptide, 6 idre 6 amines idre hexapeptide. So, ಆ ತರ ಹೆಸರಿಟ್ಕೋಬೇಕು, tetra, penta and hexa. Clear? Next, when the number of such amino acids is more than 10, then the products are known as polypeptides. So, ಜಾಸ್ತಿ ಅದಕ್ಕಿಂತ ಇದ್ರೆ polypeptide ಅಂತ ಕರೀತಾರೆ. So, this is a polypeptide structure. It will be continued. Okay. Next, protein is defined as a polypeptide with the more than 100 amino acids. So, this is also important, guys. Protein is also considered as a polypeptide itself. Why? Because it has almost more than 100 amino acids residues which are having a molecular mass higher than the 10,000 U. It's actually having a molecular mass higher than the 10,000 U. Next comes classification of proteins. Classification of proteins means they can be classified into two types on the basis of their molecular shape. Okay, on the basis of their molecular shape, they have been classified. First comes what? Fibrous protein. When the polypeptide chains are held together by H and S2 bonds. Okay, whenever they are held together by H and S2 bonds and run parallel, then fiber-like structure is being formed. What? Fiber-like structure is being formed when the polypeptide chains are held. Polypeptide chains are held together. Polypeptide means what? More than 100 units of amino acids. Clear? So, that more than amino acids of 100 amino acids, that actually is like a structure has been formed. Clear? Proteins are generally insoluble in water and are quite stable against a moderate changes in the temperature and the pH value. So, proteins are not possible to completely mix with the water. For that purpose, whenever you are having a protein, we need to have a good amount of water to get it digested. Because it's very difficult to get it digested. Clear? So, example, keratin present in the hair, wool, silk and myosin which is present in the muscles. Clear? Next comes the globular proteins. In such proteins, the polypeptide intermolecular chains gets folded to give a spheroidal shape. Due to the intermolecular hydrogen bonding, van der Waals forces, dipolar interaction and a disulfide bridging, these are usually soluble in the water and change with the change in the temperature and pH. So, this is opposite of the last one, okay, which is opposite of the fibrous protein. Like globular protein il enagutte, illi ella dipolar interaction will be happening, and actually it is usually soluble in the water also, which we have it also. Like example, insulin hakoteva navu, albumins, enzymes, hemoglobin and antibodies. These are all soluble in the water and they have a dipolar interaction. They have a dipolar interaction. Clear? Next comes the hydrolysis of the protein. So what is the meaning of an hydrolysis of the protein? In hydrolysis of a protein, we are going to learn few more things. First one is what? Simple proteins, and then the conjugated proteins. Okay. Simple proteins on the hydrolysis, they give only a amino acids. Simple proteins in badutte, amino acids ana form madutte. Next comes what? Conjugated proteins. Okay. These are having the non-protein prosthetic group, and on its basis they are going to be following the three types. First is nucleoprotein, glycoprotein, chromoprotein. So nucleoprotein means what? These are here are prosthetic group and is nucleic acid. Example, it is going to be nucleosin. Okay, and the glycoprotein here is the prosynthetic group and is any carbohydrate, example lysine. Okay, then the chromoprotein, here are the prosthetic groups in which the any pigment having a metals like FeCu are going to be what? Chromoprotein. Clear? So derived proteins are how much? Third one is derived protein. They are achieved by the partial hydrolysis of a simple conjugated proteins. So partially hydrolysis of the simple conjugated proteins. Clear? Next comes the structure of the proteins. What happens in the structure of the proteins? Amino acids are being joined together by an amide linkage. So amino acids are being joined with the help of the amide linkage. With the help of the amide linkage called as peptide bond. It is called as what? Peptide bond. Proteins are long polymers of amino acids which are linked by the peptide bonds. So proteins are all a long, actually amino acids long, like this structures will be present. Wait, I'll show you. Yes, this is how the structures will be formed. Okay, this is how the structures will be formed. Understood everyone? E tara structures form irutte. That is only called long protein like structures they will be having. Okay, they will be having a very long structure of a proteins. Then yes, next comes the primary structure. So Frederick Sanger gave the primary structure of the insulin for the first time, and the proteins may have the one or more than one polypeptide chains. It has one or more than one polypeptide chains. Okay, and amino acids of each polypeptide chain is a protein are joined to each other in a specific sequence, or this sequence is termed as a primary structure of that protein. It's termed as what? Primary structure of that protein. Secondary by intermolecular H bonding between the carbonyl and the amino group. Okay, intermolecular H bonding between the carbonyl group and the amino group. Clear? There is a regular folding on the backbone of the polypeptide chain. So there will be a regular connection in the backbone. Clear? Regular connection will be present. So how the structure is forming? This is the how the structure will be there. Regular H bonding will be happening at the back side. Okay, at the back side of the backbone. Then next comes alpha helix structure, and then we have beta pleated sheet structure also. Okay, alpha helix structure it is one of the most common ways in which the polypeptide chain forms all possible hydrogen bonds by twisting into the right hand screw. By twisting it into the right hand screw, where with the NH group of the each amino acid residue hydrogen bonded to the C double bond O of adjacent turn of the helix. So stabilization of this alpha helix configuration by hydrogen bonding. Example of alpha keratin in skin, nails, myosin in muscles. These are all examples we can give it. Okay. Beta pleated sheet structure is how it is actually all peptide chain are stretched out, completely stretched. It's not like this. Okay, it's completely stretched. Completely stretched. Okay, this is how the beta pleated sheet structure of protein is gonna look. It's completely stretched completely. Okay, where it went, and the lead side of the side by side, which are held together by a intermolecular interaction. This is how the intermolecular interaction will be there, and it will be in the form of a structure. Okay, it will be in the form of a structure. Next comes the tertiary structure. Tertiary structure. The tertiary structure of a proteins represents the folding of the polypeptide. It actually represents the structure of the polypeptide chains, or folding of the secondary structure. Folding of the secondary structure of a protein. Secondary structure of a proteins. Clear? So this tertiary and secondary structures of proteins are stabilized by force of H bonds. Force of H bonds, that is disulfide leakages, van der Waals leakages, and electrostatic force of attraction. Clear? So it gives rise to two major molecular shapes, that is fibrous and globular. Fibrous and globular. Quaternary structures, some of the proteins are composed of more than one polypeptide chains. It's actually having more than one polypeptide chains. It will be referred as what? Subunits. It will be referred as subunits. Clear? Understanding? Yes. Next comes how the primary structure, tertiary structure and quaternary structures looks. You can just observe here itself. Everything is there in one single picture itself. Okay. This is how the primary structure will be present. This is how the secondary structure will be present. This is how the tertiary structure will be present. And this is the quaternary structure. Clear, everyone? Understood how the structures? This is, you should have a 3D structure in your mind also. Okay. Yes, ಯಾವ ತರ ನೀವು 3D structures mind ನಲ್ಲಿ ಇರುತ್ತಲ್ಲ ಅದರ ತರ ನಿಮಗೆ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಇರುತ್ತೆ. ಈ ಪ್ರೈಮರಿ ಹೀಗಿರುತ್ತಪ್ಪ. Then afterwards you'll remember the points and you can write the functions of them. Okay. ಈ ತರ ಸ್ವಲ್ಪ structures ಅನ್ನ images ಅನ್ನ ನೋಡ್ಕೊಂತಿರ್ಬೇಕು ಆಯ್ತಾ. Next comes the denaturation of the proteins. This is not that important, but I will be given in the notes to you people. You need to do it. Okay. Oh, sorry. Okay. Then we will come now for the lipids. Okay. Lipids are generally not soluble in the water, and lipids are very simple fatty acids carbonyl group, and it is attached to the R group to form a fatty acid. It's attached to the R group of a fatty acids, and it is can be ethyl, that is C2H5. The group will be what? C2H5, or methyl, that is CH3, or higher number of CH2 groups. Okay. Next comes what? We will have a one second. This is the structure how it will be. R1, R2, R3 are a fatty acids. Clear how the fatty acids will be looking? This is important too. Okay. Done. Next comes enzymes, the biologically catalyst which can increase the rate of the biochemical reactions even under the mild condition. Even under the mild conditions of temperature and pH of the living organisms are termed as enzymes. How it is termed? It is termed as enzymes itself. Okay. And the enzymes are chemically similar to the globular proteins, and they are very specific for each reactions and for every substrate and every substrate. Clear? How the reactions will be formed with the help of the maltose, that is also has been given. Clear? Next comes what? Next comes the vitamins. So they are organic components. First we studied about the lipids, and then the enzymes, and then the vitamins. Okay. They are organic compounds which are required in the small amounts in our diet, but their deficiency causes a specific diseases. Okay. If in case we don't have a vitamins, we will have a diseases. What type of a diseases? You people already learnt it. Okay. Now plants can synthesize almost all the vitamins, but most of the vitamins cannot be synthesized in our body. So plants and prepare ಮಾಡುತ್ತೆ. Different types of vitamins ಅನ್ನ prepare ಮಾಡುತ್ತೆ. But ಸ್ವಲ್ಪ vitamins ಏನ್ plants prepare ಮಾಡುತ್ತಲ್ಲ ಅವೆಲ್ಲ solubility ಆಗಲ್ಲ ನಮ್ಮ human body ಅಲ್ಲಿ. Okay. Some vitamins will not be digested by our body. Clear? And some vitamins produced by bacteria of the gut. Okay. Yes. Some vitamins also will be produced with the help of the bacteria which is present in our gut. Clear? Vitamins are categorized by alphabets, that is A, B, C, D. Okay, and even we have termed as subgroups also, B1, B2, B6, B12, those also things will be present. Okay, this is the common knowledge. Definition. Classification of vitamins, Nali. First one are the fat soluble vitamins. Here what happens, vitamins which are soluble in oils and fats, okay, all soluble in oils and fats but not soluble in the water are to be considered in this group. Okay, which is not soluble in the water, but it is soluble in the oils and fats are going to be considered fat soluble vitamins. Clear? And they are vitamin A, D, E and K. Okay, which are those vitamins? They are going to be A, D, E, K. And these can be stored in the adipose, that is fat storing tissues, and a liver. Fat storing tissues and a liver. Next, water soluble vitamins. Vitamins which are soluble in water but insoluble in fat or oils. It's insoluble in the fat or oils but it is soluble in the water. Okay. Vitamin B and C are soluble in the water, so they can be grouped together. So vitamin B and C will be soluble into the water, so they can get grouped together. Means they are same family. Okay. So this is also important. You can just go through this. Okay. ಯಾವ vitamins ಇದೆ ಅನ್ನೋದು. Okay. Nucleic acids, for every species, every generation resembles its ancestors in many ways. So for this transmission, one second guys. Okay, for this transmission of inheritance characters, nucleus of the living cell is responsible, which is termed to be hereditary. Okay, which is going to be termed as a hereditary. Clear? So like this only I have given you extra points to you people to remember them. Okay, we have a few structures also according to them. Okay, you know the structures of pentose sugar hege kanutte. This is a beta D ribose. This is important guys. Okay, it's important badu pentose sugar hegirutte. How the pentose sugars will be present. Next, the bases, how will be pyrimidine, what is the structure of a pyrimidine? It is a purine, important. Then Chargaff rule is also important. Okay, you should go through the Chargaff's rule also. Next comes the structure of a nucleic acid also. Nucleoside is present, where it is a unit formed by the attachment of the base to one position of the sugar, where sugar plus base is going to be the nucleoside. This is a nucleotide. It is a nucleoside and it is a nucleotide. There is only simple difference is present there. That is going to be here. It has been attached, concentrate, a nucleotide unit formed by the attachment of the base one position of sugar and attachment of the phosphoric acid with the fifth position. This is the fifth position which has been attached. Okay, and this is a base position. Clear? That is going to be the nucleotide. Okay, nucleotide. Then double short helix structure of DNA is in this way. This is how the DNA looks actually. Right? This is how the DNA will look. You know already DNA. The sequence of the bases along the DNA or RNA chain shows the primary, structures of this and controls the specific properties of the nucleic acid. An RNA molecule is used in the single chain of the ribose containing nucleotides, and the DNA consists of two long strands of a polynucleotides coiled around each other in the form of double helix, in this form. Okay, this is how the form of double helix it will go. Actually it will be coiled, but here it is shown in the way to make you understand. So RNA is also there, single stranded helix is present, which will be there. Okay. DNA fingerprinting is there. This is also important guys, DNA fingerprinting. So here DNA cannot be altered by any known treatment and the same for every cell. It is now used for the determining the pathology of an individual also. Means in forensic and all they will use these things like use ಮಾಡ್ತಾರೆ ಆಯ್ತಾ. ಅದಕ್ಕೂ ಯೂಸ್ ಮಾಡ್ತಾರೆ. Next comes the hormones. They are actually a molecule that act as an intermolecular messengers. So hormones are substances or biomolecules manufactured in a minute amounts in endocrine or ductless glands. Okay, ductless glands. So they are carried directly into different parts by the bloodstream, and the major hormones secreting the glands include the intestinal mucus and even the pancreas, adrenals, thyroid, pituitary, ovaries, and the testes. Okay, and we have a types also: steroids, glycosides. I have given full functions of them also. You can go through those functions also. Okay. So I have given some questions to you people. You can try these questions also. Like disaccharides is formed when two monosaccharides are bonded together by a bond. So which is that bond? Come on, try this. Try this. What will be the answer? So answer A, that is when two monosaccharide units come together, they lose a molecule of a water and they form an oxide bond. Okay, they form an oxide bond. Okay, so for that purpose only, glycoside linkage is a bond formed by an oxygen atom between the two monosaccharide molecules. Two monosaccharide molecules is getting bonded up with the oxygen. It is getting bonded up with the oxygen. Clear? Next, which of the following statements about starch is incorrect? It gives a blue color with iodine. It is a polymer of a alpha D glucose. It is a reducing carbohydrate, or it consists of a branched chains. Try. Yes, because it does not decrease the film solutions or Tollens reagent. We discussed this, and is a non-reducing saccharide, and it means that all hemicentral hydroxyl groups of a glucose units are linked by glycosidic bonds are not free. Clear? So the option C will be the correct answer. One second, guys. Option C will be the correct answer. Clear? So I have given few more questions like this. You can go through the questions once. Okay, you can go. I have given the solutions also with that. So by this, let's end the class for today. So biomolecules is the easiest chapter. Try to make the understanding. Na solpa tricks kalside nimage. A tricks ana follow ಮಾಡಿ structures ನೆನಪಿಟ್ಕೊಳ್ಳಿಕ್ಕೆ easy ಆಗುತ್ತೆ. ನಾನು starting ಅನ್ನ ಹೇಳಿದ chapter is very easy if you people will understand the concepts properly. Okay, so ಯಾಕಂದ್ರೆ structures draw ಮಾಡೋದು ಒಂದು tricks ನೆನಪಿಟ್ಕೊಳ್ಳಿಕ್ಕೆ ಬೇಕು. ಎಲ್ಲ structures ನೆನಪುಳಿಯಲ್ಲ easily. So make sure you will follow these things, then biomolecules will be very easy. Okay, we'll have a PYQ sessions separately also for this chapter, but till then be perfect with the theory. You people will practice the theory, then only it will be easy. Clear? Till then, see you everyone. Bye bye.